Sir Ganapati sir.
Sir.
Sir, thank you for joining, sir.
Thank you, sir. Thank you, sir.
Okay, sir. Sharp about 10 o'clock ஆரம்பிச்சலாம் sir.
Okay, sir.
Participate ஒரு 50 cross ஆயிட்டோம் sir. நம்ம அவரே.
Okay, sir. நீங்க சொன்ன உடனே ஸ்டார்ட் பண்ணிடுறேன் sir.
Okay, sir. Thank you, sir.
Okay, sir. Thank you.
जो लोग जिस काम के लिए बने हैं ना उसी के लिए ठीक है, बच्चा उससे झाड़ू पोछा बर्तन भी नहीं होगा।
30 participants. 31 participants है अभी.
मैंने यहाँ से नेट बंद कर दिया.
Happy morning, all. It's the day 2 in this STTP series on machine learning. So today's session topic is on data analysis and machine learning using Python, which is going to be presented by the speaker, Dr. S. Ganapati sir. We are honored and privileged to have participants from various prestigious institutions across India to join this session. I thank our college management and our CEO, Sri Sai Prakash Leomuthu sir, for arranging this STTP series. And also, I want to thank AICTE for sponsoring this series. I thank our principal, Dr. K. Parnikumar sir, Event Coordinator Dr. B. Sridevi Ma'am, HOD Department of CSE, Event Co-Coordinators Mr. Jaychandran Sir and Mrs. Rajalashmi Ma'am for making your presence in this event. With this brief intro, let me introduce the speaker of this session, Dr. S. Ganapati Sir. Dr. S. Ganapati Sir, Assistant Professor, Department of Computer Science and Engineering, VIT Chennai. He has his doctorate in CSE from Anna University. He has published 80 plus articles in journals and conferences. He has over 13 plus of years of experience in teaching. Now I request our speaker, Dr. S. Ganapati sir, to take over the session. Please, sir.
Okay, thank you. Thank you very much. So I hope you are doing well. Good morning to all present here. So today's session, I am going to handle the title of Exploratory Data Analysis using Machine Learning with Python. Okay. So today I'm going to cover the following topics. What is data first? What is data analysis? What is exploratory data analysis? Then what is machine learning? Machine learning with Python. What are all the libraries available? What are the commands available? I'm going to give all the source code how to work with Python. Okay, next data analysis with Python. What are all the data analysis functionalities available in the Python? Okay, so first of all, what is data? Okay, so I hope majority people, faculty, I think so. Okay, even though you already knows about what is data mining and machine learning and all, even though, okay, so around 110 slides I am having for this session. So I will, so 1.5 hours okay, allotted for me. So I can complete this entire slide. So first of all, I will take some time, okay, for introductory sessions. Okay, so totally 60 slides I am having. So I will go a little bit fast in the introduction section. Then when we enter into the Python, okay, so automatically will get slow. Okay, so first data. Okay, so data already you knows that whatever the information, whatever the data you are going to feed, data is the whatever the value or information you are going to feed as a into the system, that is considered as a data. For example, student record, okay, name is the one of the data, okay, and the registration number, mark 1, mark 2, everything also. Okay, so this case, the data is a set of values, okay, different set of values, okay, all the collection of these different fields considered as a data set, okay, or record set we can say. Okay, so it is a qualitative and quantitative variables. So it contains the qualitative and quantitative values variables. Okay, so different variables will be allocated for each and every value, whatever the values you are going to give as input to the system. Okay, so next it is information in raw or unorganized form. Okay, so it will not be an organized form. Okay, it is unorganized form. So automatically the data will be handled by the tool or machine. Okay, it may be a fact, figure, character, symbols, etc. Whatever it may be. So that will be analyzed by the machine and produce the result. Next, information. It is a meaningful or organized data as information. Okay, so meaningful data only will be considered as information. So that is why they mentioned the qualitative and quantitative. Okay, it may be the meaningful data or meaningless data. So it should be the right data, okay, with value and sufficient quantity. Okay, so next data analysis. So data analysis, here we are going to find out anything, okay, so about a data set, you first understand the data set. First of all, we have to understand the data set. Okay, what are all the information available in the entire data set, and what we are going to find over there. Okay, so this is the objective, this the result I need for the given input. Okay, so that can be received or extracted from the given data set. Okay, for if you want to extract anyone information, we must understand the data set and we have to analyze it. Okay, so that is the data analysis. We are going to analyze the inputs, okay, data, whatever we have. Next, basically, it getting a feel for you. Numbers, okay, easier to find mistakes. Okay, that is easy way. So we are set. Okay, whatever the volume it may be. Okay, we can guess it easily to by end of the data analysis. And to find odd values. Okay, so available in the entire. These are all the things can be easily identified by using the data analysis. At the same time, analytic is the discovery. Okay, discovery, interpretation, and communication of meaningful patterns or summary data. Okay, so we are going to identify the meaningful pattern, whatever the information available in the entire data set. Okay, so the already whoever studied data meaning, you aware about, so that is in association different patterns can be. So these are all the common. Okay, particular things. So next, data analytics. So data analytics is the process of examining the data sets. Okay, so process of examining the data set, we are going to evaluate or identify the reasonable or anything, any kind of patterns we can get it. Okay, not about the content. At the same time, in analytics is not a tool or technology. Okay, we are going, okay, data, whatever the data we have. Data analysis, it is nothing but the analysis of data sets. It's various numerical methods and graphical tools. Okay, we are going to analyze the data set by using the numerical methods. Numerical methods, the statistical formulas. Okay. Can you hear me?
Yes, sir. It is audible, sir.
It is audible. Okay. Okay. Thank you. So that is another definition. We can say approach or philosophy for data analysis that employs a variety of techniques. Okay. Most of the more graphical format, graphical structure used for representing the data. Okay. In what way we have in the data. Okay. So what are all the different items we have, data sets, data we have in the data set that can be represented in how it is available in the data set. Okay, that formation can be represented by using different graphs. Okay, so that is another one. what happened? It is not working. Sorry, I'm trying to move the slide. It is not moving. Okay. Next, what is machine learning? Okay, so machine learning is the study of algorithms. Okay, so learning data mining we are to do. Okay, from the large volume of data. So machine learning algorithms, machine learns that will be analyzed. Okay, that will be analyzed, and it can be produced the reasonable output. Okay, so next one is the perform some task. Okay, it is able to improve the performance, and also it will take care any task whatever we have assigned. Next one is with the experience. Okay, so with the experience, so in what are all the experience we have gained over the data set, that can be formed as a rule, okay, as a different set of rules, and we can feed into the particular machine learning algorithm. So machine learning algorithm refer the rules and regulation whatever we feed, okay, feed in that system, okay, that will be referred and it will react. And the main thing is the mainly the whatever the rules we have feeded over there, so everything will be used for making decision over the data set. Okay, that is the main thing here. Next, optimize the performance. Okay, criterion using the example data or past experience. Past experience we discussed a lot in the previous point. Next, roll up statistics. So inference from a sample. Okay, so automatically the inference taken from the sample data sets whatever we feed. Okay, so the statistical formula will be used for analyzing the data. Next, roll up computer science efficient algorithms to, okay, solve the optimization problem and representing the evaluating the model for inference. Okay, so this is what we have in the introduction of machine learning. Okay, so next we can move to the, yes. So next, what is Python? Okay, how it is working? Python is a popular programming language. Okay, it created Rosam and released in 1991. Okay, so Python programming language mainly used to analyze the data. Okay, so we can use that, and it can, this Python programming language used to create web application. We can create web application. Already we knows that the Python programming language is a lightweight programming language. Okay, so earlier stage before the earlier introduction of this Python programming. Okay, so we used Java programming, .NET, and so many programming languages we have used. But comparatively, this Python programming, it is very lightweight. Okay, it will take the fraction of the seconds only for analyzing the large volume of data. Okay, so the Python can be used to alongside software to create the workflows. Okay, at the same time, the Python can connect to database systems. Okay, so usually the separately we have the comments for connecting the database in different programming languages. Here also, okay, by using single line, we can connect the database. Whatever the database or Excels, okay, or a data set you want to import into the system directly, you can open the specific data set, okay, by using a single function. Okay, so simple function also. Okay, so that much of facility we have in Python programming. It can also read and modify the files. Whatever the files we have, we can read and modify that. Okay, so and Python can be used to handle big data, okay, and perform the complex mathematics. Whatever the, that is why I said it is lightweight. It will take very less time than other programming language. Whatever the complex mathematical formulas you have incorporated in your system, it will handle easily and automatically produce the accurate result. Okay, so in short time. Next one is Python can be used for rapid prototyping and or for protection. Okay, ready for software development. Okay, so next one is we can move to the exploratory data analysis. What is EDA? So the analysis of data sets is based on various numerical methods and graphical tools. Already we have seen this one in the first slide itself. And another one is exploring data. Okay, so it is able to explore the different kind of patterns, what are all the trends available in the entire data set, and what are all the structure, okay, specific structure we have in the entire data sets, and what are all the deviations, okay, in the different set of record sets we have, and anomalies we can identify it, okay, and the strange structures also we can explore it. Okay, it facilitates the discovering unexpected as well as confirming the expected. Okay, so both things we can identify through the exploratory data analysis by performing exploratory data analysis. And another definition they given the as an approach philosophy for data analysis that employs variety of techniques. Okay, so mostly graphical. Okay, so this is the textbook, the very old textbooks. Okay, 1977. Okay, the John V. Turkey. Okay, that is exploratory data analysis available. Okay, so the textbook contains the information. Okay, the conformity, introductory, many basic techniques. Okay, and the number summary like this. Okay, so all these things used in this EDA. Okay, so the aim of the EDA, so for what purpose we have to do the data analysis, exploratory data analysis, the maximize the insight into a data set. Okay, so next one is uncover underlying the structure. Okay, extract the important variables. What are all the kind of feature selection? Okay, so what are all the variables can be identified as important? Okay, those columns of the values only will be used for performing classification. Okay, next one is the detect the outliers and anomalies. So what are all the irrelevant data available in the entire data set that can be identified and detected? Okay, next one is test the underlying assumptions. Okay, so we can identify the testing process and what patterns we have to test and what way. Okay, next one is develop valid models. Okay, so valid models can be developed by using this EDA. Okay, next determine the optimal factor settings. Okay, optimal factor settings we can determine here. Okay, so another one is the goal of EDA is to open mindedly, okay, explore data. Okay, so in this book, okay, to that previously I shown that book. Okay, that book is showing that EDA is a detective work. Unless detective finds and clues, judge or jury has nothing to consider. Okay, so that is another one is the confirmatory data analysis goes further and assessing the strength of the evidence. Okay, so these are all the we are going to justify judge the entire data. Okay, so in the way of pattern or experience, okay, and irrelevancy, relevancy, so everything also. So next with the EDA, we can examine data and try to understand the meaning of the variables. So what are all the variables we have in the entire data set? That meaning easily can be understood by the analyzer. okay, with the help of EDA. Okay, next the comparison of exploratory data analysis, okay, and confirmatory data analysis. So see here, EDA and CDA. In EDA, there is no hypothesis at first. In CDA, start with the hypothesis. Okay. So at the same time, in EDA, generate hypothesis. Okay. I hope you all know about hypothesis. What is a hypothesis? Hypothesis is a structure or format. Okay. This is the format is acceptable for reaching for accepting, like that, for acceptable patterns or successful or goal patterns, any combination. Okay, so that we can set as hypothesis. Okay, so next, test the null hypothesis also. Okay, uses graphical methods mostly in EDA, but uses statistical models in CDA. Okay, so this is the major difference between EDA and CDA. Okay, at the same time, steps of EDA: generate good research questions. Okay, we can create good generate good results, performing the exploratory data doubts and so many data. Automatically, we can get the awareness. Okay. About okay, we can get more knowledge about data set. And if next, instead of using two variables, another one is creating interactions, relations, and multi-correlary, if any. Okay, so we can identify that the variables. Okay, confounding variables and interaction relations. So what are all the relationship it has between the different variables? Okay, next, handle the missing observations. Okay, so final point, we can say that decide on the hypothesis based on your research questions. Okay, so another one is the after the EDA. Okay, after performing the exploratory data analysis, what we can do? So verify the hypothesis by statistical analysis. Hypothesis is a condition, the pattern. Okay, which kind of pattern we are expecting or we need as a result from the end of this exploratory data analysis. Okay, so next we can get the conclusion over the data analysis and present your results. Okay, so these are all the things we can get after performing the EDA. Another one is classification of EDA. So what are all the different exploratory data analysis techniques? We can say the first one is generally cross classified into two ways. Okay, first one is each method is either non-graphical or graphical, and the second one is either univariate and multivariate. Okay, univariate, it is based on the specific thing, only one parameter. Okay, and multivariate, we can use the different parameters for analyzing the specific data. Okay, so next, non-graphical methods generally involve the calculation of summary statistics. Okay, while graphical methods obviously summarize the data in diagrammatic or pictorial way. And another one is univariate methods. It is a data column, only one column, look at one variable at a time and analyze it. At the same time, while multivariate, look at two or more variables. That is why already I told you that so many, more than one variables will be considered for analyzing the data. Okay, so another one is this is the example. Okay, example one, we can say data from the places rated. Okay, almanac. This is one standard example they given. Okay, so first one, climate, mindless, housing, cost, healthcare, environment, crime, like that. Okay, different kind of things. Okay, here we can raise the question: how is climate related to location? So if we have climate related data, so we can raise the question. Okay, another one is, are there clusters in the data? Okay, excluding the location. If we have a location information over there, so we can ask that question. And are nearby cities similar, or any relation between the economic and outlook crime? Okay, crime data we have. So like that. Okay, another one, the breast cancer research. Okay, so many people are working on breast cancer analysis. Okay, data analysis. Okay, so here also, does any treatment method result in a higher survival rate? Okay, can a particular treatment be suggested by women with a specific characteristics? Okay, this kind of question may rise when we use the cancer data set. And another one, third example in a project, the investigating the well-being of teenagers after an economic hardship. Okay, so the in this project also investigation related, okay, things, teenagers after an economic hardship related information we can raise the question. And example 4, okay, cancer cases, okay, analysis. So what is the ID, what is the gender, what is the age, what is the date, okay, when they affected, and site. Okay, so like that. Okay, so this is a small data set. Here we can find the necessary information. So what are all the age group people are getting affected by the cancer? Okay, cancer, and what duration for the specific period. Okay, so this kind of what gender people affected with the cancer. Okay, these are all the different data sets. Okay, so what are all the question can be asked, okay, or raised from the data end of the exploratory data analysis. Okay, that is a short introduction, okay, about the exploratory data analysis. Another one, we can move to the machine learning with Python. What is the relationship between the machine learning algorithm and Python? Okay, so here topics, what are all the topics I plan to cover? Introduction to machine learning, supervised learning, unsupervised learning, next Python libraries for machine learning. Okay, so these are all things I have planned. Okay, so what is machine learning? So machine learning to learn by extracting patterns. For extracting the specific patterns, okay, the machine going to learn the data set. Whatever the data set we feed to the system, particular machine, that machine will learn the available information and find the patterns. Okay, whatever the patterns we are expecting from the machine. Okay, so next one is the machine learning is an idea to learn from examples and experience. Okay, so whatever the conditions we have given, okay, whatever the rules we have given, that is the experience only we are feeding in the form of rules, okay, into the machine learning algorithm. Okay, so, and also we can give the during the testing process we can give the samples also. Okay, for this kind of question. Okay, so this will be the answer like that. So usually you aware about the training data set and testing data set. Okay, so training data set, usually the 33% of data set can be trained and remaining thing will be tested. Okay, so here that training data set will have the result column. Okay, so whatever the inputs we are giving, okay, and also the prediction result also will be available in the end of the column. Okay, column in the whole data set. So the 33% of whole data set having result column, that will be given to the system or machine for doing the training process. Okay, the end of the training process, machine extract some patterns. Okay, so patterns and examples, everything also from the patterns, from the training process. So the training process will give the sufficient information about the nature of data and the relationship between the data, and what are all the features will be contributed for identifying the particular disease or anomalies or normal, abnormal, like that. Okay, so all that relationship, everything also observed from the given data set, okay, by the machine. Okay, so based on the training, automatically when we feed the testing data which is not having the result column, okay, the testing data also, the machine it will train, it will analyze the data according to the, okay, received information during the training process. So whatever the patterns identified by the machine during the training process, that will be applied here during the testing process. And if it is matched, means automatically what kind of result already we feeded, okay, as a training data set, okay, that will be given or shown to the user. Okay, so that kind of activity only going here in the training and the testing process. Okay, so next another is Python. Okay, Python is a popular platform used for research and development of protection system. Okay, it is a vast language with a number of modules, packages, libraries that provides multiple ways of achieving a task. Why nowadays we people are everybody is moving to the Python programming. Python programming, it is very, very, very easy. How the Windows operating system getting full market, okay, of the market, okay, by providing the guide, okay, graphical user interface, okay. So the earlier stage in DOS operating system, everybody is, okay, we must aware about the commands to enter into the system to create a file or modify the file, delete the file, whatever the operation you want to do, we must aware, we must know the relevant commands. Otherwise, we cannot work in the DOS operating system. But at the same time, when they introduce the Windows operating system, all the people are utilizing the system easily. Okay, because of by seeing that whoever able to read the English, okay, read the English and understand the English, automatically they can operate the computer. Okay, that situation happened in earlier stage, okay, after the introduction of Windows operating system. Similarly, okay, nowadays the people are all the data, specifically data analysis people, okay, data science people, everybody is moving to the Python. Okay, so without the by using Python, we can implement very large project also. Very big project can also implemented simply. Okay, because of for example, for feature selection. So feature selection, so we have to read the input and observe what are all the variables available, and we have to write the code for reading one by one in the column wise or row wise, and we have to take a backup and process the do the calculations. Okay, after that only we can get everything. Okay, so that is normal things going on. Okay, so for that purpose, we are in the position to write a number of lines of code for performing the small, for example, noise reduction, the null value remove. Okay, we want to remove the null value, do the, okay, sufficient, we must write the sufficient number of code, then only it will work, otherwise it will not work. At the same time, in Python, just we can call the simple function. Okay, so function, so everything also available as a package. If you want to do the data pre-processing classification, or if we need the top 10 columns or top 10 rows, or who are the topper of the particular class, who got highest salary in the particular list, so whatever the queries, okay, whatever the information we need, everything available as a package, separate package. Okay, so all the packages also available in different libraries. When we call the specific library, so we can use the particular package for performing the data analysis. That is why nowadays people are moving libraries. We have NumPy, Pandas, SciPy, and Scikit-learn, and Matplotlib library. Okay, so these are all the libraries are available. Okay, so majority people are the NumPy, Pandas, automatically the everybody's three libraries, all the simple data analysis also we have to upload that, sorry, import that. After that only we have to do. When we need to present our data in visualization format, we need to, okay, in load or import the Matplotlib library used for creating scalable So okay, sorry for the disturbance. Okay, so many times it is my due to poor network connectivity, it is disconnecting. Okay, sorry for the okay gap. Okay, so next we can continue. So the Python implements popular machine learning techniques. Okay, classification, regression, recommendation, clustering, everything also. And also it offers a ready-made framework for performing data mining task. Whatever the data mining task we did using the different kind of tools. Okay, or we have the codings. Okay, so everything also we can do it in Python also. Okay, by using the predefined functions packages which are available in Python programming. Okay, at the same time it will take very less time than the previous tools whatever they achieved. For example, Veka tool, it is a famous tool, everybody is used, I think so. So that Veka tool, whatever the time it is taking for pre-processing, okay, so less than that only the Python programming will take for performing the same pre-processing or clustering or classification. Okay, so that is why this Python programming is efficient than other programming languages for performing the data analysis. Okay, and the data mining algorithms, implement the data mining algorithms also. Okay, so next one is data science, machine learning, and artificial intelligence are some of the top trending topics in the technological world today. Okay, the data mining and Bayesian analysis are trending, and this is an adding the demand for machine learning. Okay, Bayesian analysis, which is working based on the Bayes theorem. Okay, so that also it is a trending. Okay, nowadays in machine learning. So machine learning study of algorithms that improve their performance at some task with the experience. Okay, so this is machine learning. Machine learning is a discipline that deals with the programming the systems so as to ask to make them automatically. So I am going to explain the whatever the term I highlighted in red color. Okay, remaining thing I will share the slide. You please go through. Okay, so I am in 28th slide only. 80 more slides I am having. Okay, so the learning implies the recognizing and understanding. Okay, that is only already we discussed a lot about the machine learning algorithm, how it is a training process and a testing process. So understand the data set during the training process, and it will take a decision over that during the testing process. Next, very difficult to consider all the decisions. Okay, so that is also very important. Okay, the different kind of patterns are differently. Occasionally, some different pattern may come during the testing process. At that time, okay, the system may get confusion. So it is difficult to make a decision over the specific type of or patterns. Okay, so next one is the specific data and past experience are built into the system. Okay, for making the decision. So machine learning algorithm, it is an automated learning with little or no human intervention. So machine will do that. Okay, so just we are going to feed the data set, whatever the analysis we can do by human being, everything also can be done by the machine. Okay, so for that purpose we have written the code. Okay, for learning the data set. Okay, training learning the data set, and for taking decision over the data set. Okay, for that purpose we have written source code over the in the form of machine learning algorithm into machine. Okay, next it involves the programming computers so that they learn from the available data, available inputs. At the same time, okay, the main purpose of this machine learning to explore and construct the algorithms and learn from the previous data and make predictions of new input. Okay, growth of machine learning. So machine learning is a preferred approaches to the speech recognition, the natural language processing, computer vision, medical outcomes analysis, robot control, and computational biology. All these and all famous application, okay, of machine learning, we can say. So speech recognition, so it is very important for the people who are not able to speak. Okay, so next one is NLP, the sentence or text, whatever the content we are feeding to the system, that will be analyzed. Okay, So next one is computer vision point of view and medical outcomes. So medical outcomes, whatever the patient records that we are feeding to the system, that will be analyzed and produce the result in different aspect, whatever we record. Okay, so next one is robot control. So robotics can be controlled through the machine learning algorithms, or we can ask them to do any activity and analyze the data. Okay, for example, the nowadays the combination of artificial intelligence and machine learning algorithm based robots available. That robotics, okay, used for assisting the patients, bedridden patients. Okay, so bedridden patients, whatever the time they need the medicine, okay, or whatever the time they need food or some other things, everything also feed into the robot. Robot will do the action. Okay, so we'll take the identify the right medicine and right food, whatever we have within the room, it will take and give it to the patient. Okay, so next computational biology. So that kind of the biological inputs can be given and analyzed. Okay, so next these are all the things available in the machine learning application. Okay, so next one is application of machine learning algorithms. So whatever we discussed, that will be, that is listed here. Okay, that are listed here: the web search, computational biology, finance, okay, e-commerce. E-commerce, in what aspect we can use the whatever the feedbacks we have collected from the customers, that feedback will be given as input to the system. So by using the machine learning algorithm, we can identify the patterns. Okay, so the most purchased items, or what are all the items purchased by the different age group and gender wise and season wise, we can identify the things. Okay, and we can increase our stock. Okay, so for the respective season. Okay, so like that. Next space exploration, and next one is robotics. Okay, we have discussed information extraction. Okay, information extraction, just data retrieval. We can retrieve the relevant information from the large volume of content. Okay, that are available in internet source or any data repository. Next, social networks and debugging process. Okay, data mining, expert systems. So expert system, it may be the medical expert system or e-learning expert system, whatever it may be. Next, robotics and vision processing. Okay, so vision processing, the eye contact. Okay, so how it is processing the images, what it is observed from the environment, that can be analyzed and give the reasonable input to the people. Next, language processing. Okay, whatever the language. Okay, nowadays the so many research works are going on. Depends on the language: Hindi language, Tamil language, English language, and Telugu, Malayalam, like that. Okay, so many NLP works are available. Okay, that are focusing over the language processing. Okay, so next one is the forecasting things like stock, market, trends, everything. Okay, so next one is the pattern recognition. Next, games. So everything also can be done through the machine learning. So benefits, why we need machine learning algorithm for performing the data processing effectively. Next, better decision making and prediction. Okay, next, quicker processing for fast processing. Next, accurate. Okay, accurate prediction. Next, affordable data management. Okay, when we have large volume of data, that can be managed easily. Next, inexpensive. Okay, it is very less cost. Okay, next one is analyzing the complex big data. These are all the main and the major benefits of machine learning. So steps involved in machine learning: defining problem, preparing data, evaluating algorithms, improving the result, presenting the result. These are all things. So we must note down here, we have a step in improving result. So what it will do? So during the data analysis, okay, it will continue the data analysis process when we until get the better result over the data set. Okay, so that is the thing happened here. Next, here we can see the traditional programming and machine learning approach. Okay, data program. Here we are feeding the both things, data and program. So the computational process will happen and the results will be produced. In machine learning approach, we are giving the data and the results, data along with the results, and doing the computation process, and we can get the program point of view. Okay, so this is the structure we have, the production. Okay, code the rules, first evaluate whether it is okay. Problem at hand, what problem we have finalized. Next, code the rules. Okay, next, review errors. So is there any errors that will be checked and okay, evaluated? Then finally we can produce it. Okay, so here also that training we have added here. Okay, train the machine learning algorithm. Okay, so the training process will be happened here, then evaluate it, and finally we can check the working process of the training, sorry, machine learning algorithm, and we can produce. Okay, so next, what speciality we have in the machine learning. So no more like gardening. Okay, seeds, algorithms. Okay, whatever the set of codes we are writing, that will be considered as seeds. Okay, next, nutrients, that is the data. Okay, what are all the valuable information we have in the data set. Next, gardener, you, okay, you are going to pick the or extract the credentials from the uploaded data. Next, plans, that is the programs. Okay, so these are all the things we have. Next, the machine learning, it is automatic automation. Okay. Next, getting computers to program themselves, and writing software is the bottleneck. Let the data do the work instead. Okay, so these are all the techniques, machine learning technicalization, classes, anomaly detection, visualization, are utilizing the anomaly detection. Okay, three components. Okay, it has the machine learning algorithm: representation, evaluation, and optimization. Okay, next one is representation. So here, decision trees. Okay, we can represent in the form of decision tree, set of rules or logic programs. Next, instances and graphical models, neural networks, support vector machine, model ensembles, etc. So many representations available for showing the performance of machine learning algorithm here. Okay, or a data analysis process. Next, evaluation. So how we can evaluate the machine learning algorithms? Okay, by achieving or getting the better accuracy and precision and recall values, and F measure values also we can add here. Next, squared error and likelihood. Next, posterior probability and cost utility, margin, entropy, and KL divergence, etc. Okay, so the majority people are utilizing the evaluation metrics, the accuracy, precision, recall, F measure, and entropy. These are all the things majority people are utilizing. Some people utilize the conditional probability also. Okay, so next, optimization. Here, combinatorial optimization, that is a greedy search method. Next, convex optimization, gradient descent, and constraint optimization, linear programming. These are all the optimization techniques also we have. So next, features of machine learning. Here, the repetitive training process. Okay, training to improve the learning and the decision making of the algorithms. Okay, that is why improving the result step we have in machine learning. So when we get the satisfied result, we can stop the learning process and we can wind up that until we can continue the process. Okay, so another one things, here, machine learning can learn from labeled data. Okay, that is a supervised learning. Okay, machine learning can learn from unlabeled data, that is unsupervised learning. Okay, so these difference already you knows that. Okay, knowing the supervised and unsupervised. Next, for example, the face detection, email filtering, medical diagnosis, weather prediction. Okay, everything also can be done. Okay, by using machine learning algorithm. Next, concepts of learning. here the supervised, unsupervised, and semi-supervised. What is semi-supervised learning? So semi-supervised, the partial 50% of data with the result column, 50% of data will be the without result column. Okay, so the mix combination of testing and the training data set will be fed as a, into the system and getting the result. Okay, so next one is the training here, supervised, unsupervised, semi-supervised, and reinforcement. What is reinforcement? That is rewards from the sequence of actions. Okay, so these are all the supervised algorithms. I explained that, no need to repeat again and again. So the categories of supervised learning. Okay, so the classification and regression. Okay, so supervised learning can be classified to. Okay, so classification here, classification problem is when the output variable is a category or a group. Okay, such as block, white, spam, no spam, like that. The regression problem is when the output variables is a real value such as rupees or height, like that. Okay, so unsupervised, to discover the interesting structures or patterns from the uh, without labeled data set. Okay, so next one is no given correct answers and the machine itself finds the answer. That is the very important here. Okay, there is no result column, but it should learn and identify the right pattern and it should produce the result. Machine should produce the result. Next, unsupervised learning is used to detect anomalies, outliers such as fraud and detective equipment. Okay, so here the last point, it is used to discover the hidden patterns to determine how to describe the data. Okay, that is the this kind of learning data is unlabeled data. Okay, so discover, identify the hidden patterns. What are the hidden patterns available in the entire data set, that will be identified and show that. Next one is the determine how to describe the data. That also it will show in unlabeled. Okay, so next one is the unsupervised learning. We have the two types. Okay, association and clustering problems. Association, that is already I discussed this association rule meaning. Okay, so what is the combination? Support, confidence, and combination. Okay, so what is the combination? We have the data. What is the relationship between the two different data? Based on that, we can identify the pattern. Clustering problem. So here you can discover the inherent groupings. Okay, based on the relationship between the data, we can group. Okay, and different groups we can form according to the user interest. Okay, so reinforcement learning. So here program will interact with a dynamic environment. Okay, so and also it is navigates the problem space, and the machine is trained to make specific decisions. Okay, so next, semi-supervised already explained. Okay, next we can move to the Python libraries. Okay, so what are all the things we have? Okay, so see here, already I explained this NumPy, Pandas, Matplot, and scikit-learn and Seaborn. Okay, so NumPy, it is used for it n-dimensional array objects. Okay, Pandas is a data analysis library that includes data frames. And another one is Matplot library. It is a two-dimensional plotting library for creating graphs and plots. Okay, scikit-learn, it is used for data analysis and data mining task. Seaborn, a data visualization library based on the Matplot library. Okay, so here the scikit-learn used to analyze the data. Okay, data analysis and data mining task. Whatever the task we want to perform, we can do it. We can call that. Okay, so next we can go a little bit slow with the Python for data analysis. Okay, so this is the overview. Okay, overview of Python libraries and data scientist. Next, reading data, selecting and filtering the data, data manipulation, sorting, grouping, rearranging, plotting the data, descriptive statistics, and inferential statistics. Okay, so this entire the remaining slides I'm going to discuss about the simple functions. What are all the functions available in Python for doing the data analysis? Okay, with a simple data set. Okay, so one data set, the employee data set, which is available in Kaggle. Okay, so that will be used here. Okay, so next one is Python libraries for data science. Here many popular Python toolbox, NumPy, okay, Scikit, Pandas, scikit-learn, matplot. Okay, visualization purpose, what are all the things we have? Matplot and Seaborn. Okay, so here Numbi, it is used to perform the to easily perform the advanced mathematical and statistical operation. Okay, so whatever the function we need, okay, we can retrieve, okay, from this library. Next one is provides vectorization of mathematical operations on arrays and matrices, okay, which significantly improves the performance. And many other Python libraries are available. You can get it, that entire library, from the prescribed website. Okay, so next, Python library for data science, SciPy. Okay, here collection of algorithms for linear algebra, differential equation, and numerical integration, optimization, statistics, and more. Okay, so everything also available in this library. We can take and use it. Next, Pandas. Okay, adds data structures and tools. Okay, we can add data structures and tools, everything. It provides the tools for data manipulation and also handling the missing data. Okay, so how can we manipulate the data? That is reshaping, merging, sorting, slicing, and aggregation. Okay, so scikit-learn, it provides the machine learning algorithms, classification, regression, clustering model, validation, everything. By calling the particular name of the algorithm, we can, okay, perform the classification operation. Next, matplot, it is a two-dimensional plotting library which produces the publication quality figures, okay, and variety of hard copy formats, everything. Okay, that is why already I told you that a set of functionality similar to those of MATLAB. Whatever the functionalities and facilities available in MATLAB, so everything also possible through this, available in this library, and we can perform the analysis, data analysis, okay, through visualization. Next, line plots, scatter plots, bar chart, whatever you want, you can do it here. Okay. Next, Seaborn, based on the matplot library only, but it provides a high-level interface, okay, for drawing the attractive statistical graphs. We can made it. Next, log into the shared computing cluster, SCC. Okay, so SCC login information, you can have an account. Okay. Next, okay, this is a starting stage. Okay, so I can I have to explain one more thing, that Anaconda you have to, okay, load in your PC. Okay, so that after Anaconda and Python, both things you must install in your PC, then only you can work this one. First of all, you have to open the Anaconda, then you can start the Python. Okay. So next, this is the module avail Python. Okay, we are checking that module load the Python. Okay, 3.6.2 version. Okay, so next, it will be checked on the shared computing cluster. Okay, on the other hand, and it can be saved in the particular given link also. Okay, so Jupyter Notebook. Okay, so nowadays the so many majority final year students are working with this data analysis project, okay, with the help of Jupyter Notebook, Anaconda only. Okay, so Jupyter Notebook, it is freely available. You can download and you can install it in your laptop. Okay, so here you can get the particular data set. See that you can open the Jupyter Notebook, okay, by typing Jupyter space notebook. Okay, so now you can get the space over there. Okay, here what we are doing here, Numbi, okay, SciPy, Panda, Matplot, Seaborn. All these are and all the different libraries. Okay, what are different libraries we have in Python. So everything also we imported here. At the same time, we have created object for all the libraries. Okay, so NP, SP, PD for Pandas and Matplot, MPL, everything. Okay, so after creating on the object for the entire libraries, you can use the whatever the functionalities available in different libraries, everything also directly you can use this notebook. Okay, that is the meaning. Okay, so first press shift enter to execute the Jupyter shell. So we can this entire cell can be executed by pressing the shift enter. Okay, so now after that, suppose if you want to read the CSV file, yes, we have imported all the necessary libraries. Okay, now we can read the CSV file, that is a data set. Okay, so data set, you can get from online also, or from local repository, your from your device also, you can read the data set. Okay, so whatever the path you are going to give here, that will take. Okay, so read CSV. So the here we use the pandas. See here, PD is the object of the pandas library. Okay, so pandas library having the predefined function read CSV. Okay, so read CSV, you can call the particular function, and within the double quotation what address you are going to give, from that it will, okay, read the content, read the data set. Next, the command has many optional arguments to fine tune the data. Okay, so here there is a number of pandas commands to read other data formats. So what are all the ways, different ways also we can read. Okay, read underscore Excel. Okay, this is read underscore CSV file. If your data set data set is available in the form of CSV, so in the CSV format you can read it. Otherwise it is in Excel, so you can, by using this one, you can read it. Okay, next column. Okay, and stata and SAS, HDF, like that. Okay, whatever the format you have used, okay, for storing the data, okay, you can use the respective predefined function for reading the information. Okay, so next one is exploring the data frames. Okay, so this entire analysis, okay, I used only one data set, that is employees data. Okay, employees data. Now what we are doing, okay, DF. Okay, so DF is the object of what? DF is the object of what we have here. So we have mentioned here DF, what data we have read from the data set. Okay, so from that we are taking the header. Okay, so now head, DF dot head. So DF having the all record sets of the data set. Okay, so now the head only will be considered here. What are all the headings? Okay, so top 5 will be displayed here. So you can read the 10, 20, whatever the, how many records you want to see, you can see. Okay, so next one is data frame, data types. Okay, so what are all the different types available? Pandas type, object, integer, 64-bit, and float 64-bit. Okay, so in native Python type is, okay, string, integer, float, everything. Okay, so we have the different data types here, and based on, now we are going to use the different type of values. Okay, handle the different type of values here. Okay, so next cell. Okay, what we have, DF of salary. So what record set you having? Okay, in the entire record set you are going to select the salary column. Okay, particular column, and the data type, what data type it has. Okay, so that data type will be shown here as output. Okay, so D type integer 64. Okay, so next one is check types for all the columns. Okay, so here DF dot data types. In this case, okay, we have rank. Okay, different disciplines. Okay, discipline, PhD, service. Okay, sex and salary, data type, everything. Okay, so what are all the different data types we have used in the entire data set? Everything also will be listed here. Okay, when we use the D types. Okay, so here we didn't mention anything. Okay, so the entire record set will be considered here for identifying the different data types, D types. Okay, so next, Python objects have attributes and methods. Okay, so here data types, columns, access, endim, okay, size, shape, and values. Okay, df dot attribute. So these are all the things you can use. Already we have seen this D types only, data types only we have seen. So you can get the columns. Okay, columns of the different different records. Okay, sorry. In the entire data set, what are all the columns you have, you can ask them to list out. Okay, so list the column names. Next, access, list the row labels and the column names. Okay, labels can be listed out. Next, endim, here number of dimensions. Okay, number of dimensions will be displayed here. So df dot size. Okay, so you can get the size of the number of elements, you can get it. Okay, shape, you can get it, and values, number representation of the data, everything also you can get it. Okay, by until this, okay, you can do these kind of small experiments. Okay, so you can find the, already I told you, you can get the columns and access, shape, values, everything also. Okay, next data frames methods. Here, unlike attributes, okay, Python methods have parentheses. Okay, see here the df method. What are all the standard methods available? So earlier we have seen the different attributes. Okay, what are all the df attributes? Only we have discussed. Next, what are all the methods we have? Head. Already we used that head. Okay, so head, what a number you are going to mention. Okay, until that you can get the all the records. Okay, so see here the head of n, tail of n. Okay, first and last n rows you can get it. What numbers you are mentioning? Okay, first 5 you needs means you can mention 5 comma tail of 5 means first and last 5 rows you can get it, first or last. Okay, so describe, then generate the descriptive statistics for numeric columns, you can get it. And max and minimum. Okay, here we can return the maximum values of all numeric columns and minimum. Okay, maximum and minimum. So when you call this max of particular, if you mention the specific column name, you can get the largest value from the particular column. Okay, generally if you call the max, df.max, if you call like that means, okay, you can get all the maximum value of the different columns, whatever the how many columns you having in the data set, everything also will be displayed. And minimum also. Next, mean, medium. Okay, the different values will come over there. Next, standard deviation all automatically will be calculated. Sample. So listen here, see all these small functions. By using these functions we are doing everything, but at the same time, okay, so if you want to do all this operation through programming means, okay, we have to write entire, okay, the large volume of source code for doing all these things. Okay, so by using these commands we can, okay, calculate the mean value, standard deviation, okay, values maximum and mean. Okay, these are all the, for example, what are all the mean values of the first 50 records, okay, in the data set, that we can calculate by using the, okay, head method. Okay, so next is selecting the data frame. So first one, subset the data frame using column. So by we can extract the specific, okay, subset from the data set. Another one is use the column name as an attribute. Okay, so df.6. Okay, so that is the column attribute name. Okay, we can use that also. Okay, by using that we can calculate the values. Okay, average salary we can calculate, what are all the salary structure we have. Okay, so next one is group by method. Okay, so group by method, what it will do, we can make a group. Okay, how we are doing the, for grouping the data, we are applying clustering algorithm, or we are writing source code for identifying the relevancy of the particular columns and values, and we will fix one condition according to that, whatever the values are values of the particular column will come automatically. We are grouping all the values, okay, as a group. Okay, so this is up to for example 1 to 10 means, okay, 1 to 5 and 5 to 7 or 7 to 10, like that we can take it. Okay, take and group it. Okay, so for that purpose we need to write the source code in other program. But here, okay, group by method, we can easily, in what way you want to group the data, you have to mention it automatically. It will. Sir? Okay, so df underscore rank.
ஹலோ
Here.
சரி சொல்லுங்க, என்ன உடம்பு சரியில்லையா? வாய்ஸ் ஒரு மாதிரி இருக்கு.
Hello.
ஏன் எங்கேயும் மலையில போய் சாப்பிடு? பக்ரீத் நல்லா.
Okay, so group data using rank. Okay, so df underscore rank, df dot group by. Okay, so what we are going to do here, just we are going to grouping the data according to the, for the rank column only. Okay, so next calculate the mean value of each numeric columns. Okay, okay, so df space rank dot mean. Okay, rank dot mean, here what we are doing, rank already we have a separate column, so there we mentioned all the designation. Okay, so next we are going to calculate the mean value for the each rank wise. Okay, so for example the associate professor, so what is the mean value for the salary? Okay, So next service, okay, PhD like that, and assistant professor and professor. Okay, so these three categories, okay, three ranks we have. How many ranks, different ranks you have. So everything will be considered here and calculate the mean value. So the entire data, whatever the size of the volume of the data set it may be, okay, it will do the consider the specific rank based all employees and calculate the mean value for the every thing whatever whatever it has. Okay, so that is PhD service and salary. Okay, so this is a very big task can be performed by calling a single function. Okay, simple function. Next, once a group by object is created, we can calculate various statistics for each group. Okay, so see here the rank and salary dot mean. Okay, so the previous function what we did here, the entire data set, that is a DF. Okay, so we according to the rank, okay, we are going to calculate the mean. So specific, we didn't specify the particular rank, okay, rank of the professor or employees, but okay, simply we mentioned the rank dot mean. So what it will do, whatever the different ranks available, then automatically it will calculate the mean value. But the next one is what we mentioned, df dot group by what of rank. Okay, so we are going to make a group according to the rank, and after that, okay, we are considering the salary. Okay, salary only, salary column only for calculating the mean value. So the total employees will be grouped by using rank, okay, different designation. Okay, then the salary column will be considered and the mean value will be calculated. Okay, so next, group by performance notes. No grouping or splitting occurs until it's needed. Okay, so the creating the group by object only verifies that you have passed a valid mapping. Okay, at the same time, here the group keys, okay, default group keys are sorted during the group by operation. Okay, so in this case, what we did, the group by of rank. Okay, so rank we mentioned, at the same time we mentioned make it sort equal to false. Okay, so then salary dot mean. So here also we are going to calculate the mean value. At the same time, there is no sorting. Okay, so calculate mean salary for each professor rank. Okay, so we can get it. So see the next one, filtering. Okay, filtering here to subset the data, we can apply the Boolean indexing. Okay, so for example, the df underscore sub equal to df of salary, and what is the salary? It is 1,20,000. Okay, who got salary above 1,20,000? Those process name will be listed out. Okay, so they calculate the mean salary for each process rank. Okay, so next one is any Boolean operator can be used to subset the data. So within the comments, okay, so in the source code part, okay, in the particular column, you can use, okay, box, you can use, okay, any Boolean operator like less than, less, greater, okay, equal, greater or equal, everything also. Okay, so at the same time, equal symbol, as usual, double equal symbol we must use. Okay, single equal is assignment. Okay, so the select only those rows that contain female process. So for that purpose, what we have to do here, we consider only those are who received 1,20,000 and above salary. So those people will be considered here. Okay, whose are the from, okay, gender, female gender, that those process only will be considered here. Okay, so next, there are a number of ways to subset the data frame. Okay, so number of ways to the subset one or more columns. We can take one or more columns and one or more rows, or subset of rows and columns, everything also. So whatever the style, whatever the way we need, we can do that. Okay, we can calculate. Okay, so another one is when selecting the possibility to use the single set of brackets. Okay, so see here the select column salary means we can mention the salary only the df. Okay, so we'll get the salary. At the same time, another one is rank wise means rank comma salary. So select the column salary only, okay, according to the ranks. Okay, so select more than one column and or make the output to be data frame. Okay, so this is the main thing here. So another one is the rows. Okay, selecting rows. So if we need to select a range of rows, we can specify the range. Okay, so we can mention the range. Okay, 10 to 20 or 5 to 10, whatever the range you are going to fix according to that, then respective records will be considered for analyzing whatever you are going to fix further. Okay, so see this one. Okay, DF sub LOC. Okay, so here what we mentioned, okay, 10 to 20. Only we are going to consider the 10 to 20 records only. Okay, so within that, what are all the columns we have mentioned? Rank, sec, and salary. Okay, so we are going to list the, okay, rank and gender and salary. Okay, based on that only, the between the 10 and 20 records. So the single only, okay, male only we have considered here. Okay, and who are all available within the 10 to 20 records, everything will be listed out at the same time. Okay, so next one is, we can move to the next one, ILOC. Okay, ILOC method, ILOC, it is used to, if we need to select a range of rows and or columns using the position. Okay, the specific position can be mentioned here. Okay, select rows by their labels. Okay, so see here the 10 to 20 we have. Okay, we mentioned that, but 0, 3, 4, 5 like that we mentioned the ILOC. Okay, so according to that, it will display the result. Okay, so these are all the ILOC. We can set first row of data frame or I plus 1th row, and the last row we can get it. Okay, first column, last column we can mention with the 0 or -1, and the first 7 rows, 2 columns, like that. So many functions available. You can refer it. Okay, and sort the data. Sorting here we are going to sort the based on the service or salary or registration number, like that, sorry, employee number, like that. Okay, so here we sorted the sort values by service. Okay, so based on the service we are, okay, sorting. Okay, service here 0, so entirely, so it started with the 0. Okay, 0, then 1, 2, 3, like that and all. Okay, so DF sorted dot head. Okay, so head, when you call head, whatever the columns we having in the data set, everything will be displayed. Okay, that already we have seen. Next, df underscore sorted, df dot sort values by service salary. Okay, see here the 2 columns will be considered for a sorting process. Ascending, true or false we can set. Okay, the sorted head of 10. Okay, so see here the service 0 to 2, we can consider all the male and female gender also. Okay, we can consider and sort them according to the service only. First started with the 0 and up to 2. Okay, so it is continuously going on. Okay, so until the first 10 records. Okay, so next one is the flights. Okay, so flights equal to pd dot read csv. So another one data, we are doing the read a data set with the missing values. Okay, so another one is we have entire data set. This is the another one data set. Okay, so the previously we have seen all the functions. Okay, for the employees data set. Okay, this is a flight data set, which is the both are available in Google. Okay, you can directly use and take and use it. Okay, here null values can be replaced NaN. Okay, so NaN is the null value that will be identified and we can remove that. Okay, so then missing value. Okay, drop NA. Okay, so drop the missing observation, drop NA how equal to all. So drop observations wherever all cells is not applicable. So similarly, access based and drop column if all the values are missing. Okay, so that this case automatically we can drop the column, entire column. Okay, so there is no value, we can drop the column also. Next, drop NA threshold equal to 5. Drop rows contain the less than 5 non-missing values. So the specific now, so what we did here, okay, just okay, check the values. If it is below 5 means automatically we can drop those rows. Okay, fill NA. So here replace the missing value with the zeros. Okay, and is null also we can be checked. Okay, so not null returns the true for non-missing values. Okay, so missing value can be checked, and we can fill with the number, or we can drop the column, everything also possible, or we can replace with some values. Okay, so next one is aggregation. So here we can compute the group sums or means. Okay, so here we can use, already we discussed about minimum, maximum. Okay, some, okay, mean value already we have discussed, standard deviation we discussed. Okay, so all these things. Okay, here some product, median, mode, made. Okay, so where everything also available. So by calling this, okay, by mentioning the AGG is the aggregation function. Okay, whatever we mentioned, minimum, mean value and maximum value. Okay, that will be displayed here for the entire data. Okay, what we mentioned, departure delay and arrival delay. So arrival. So these two information will be displayed with the minimum and maximum and mean values. Okay, so these are all the statistics, basic descriptive. Okay, minimum, max, mean, median, mode, variable, everything. Okay, so next we can graphics. Okay, graphically how we can show the things. Okay, so until we did the numerical value analysis only, now we are going to see the graphical structure. What are all the graphical structure? Okay, we have, okay, distance plot, bar plot, okay, violin plot, joint plot, regression plot, okay, pair plot, box plot, everything. The graphical format we can do it by using the standard methods. Okay, so the entire thing available in online only. I didn't take newly anything from any other things. Okay, so everything available in online. Whoever wants to use Python programming for your own research work or any other project work or experimental analysis, you can do it by referring the online material. This is the just an eye-opening session, I think so. So you can aware about the Python. Okay, for implementing the data analysis. Just I shown the data analysis. So we can call the clustering, classification, whatever the algorithm available. Okay, machine learning algorithm, you can use it. Okay, even the deep learning algorithm also available. You can take and utilize and go forward with your, okay, intelligent research. Okay, thank you so much for your patience and for giving this opportunity. Thank you for the committee, coordinator and HOD, everybody's. Thank you.
Thank you, sir. It was a wonderful session. I request participants, if you have any queries, do type in the chat box. We'll pick your question and ask our speaker.
Question, please. Whatever the question it may be, your research aspect or project aspect or experiment, lab experiment, whatever it may be, you please ask me.
I repeat, participants, if you have any doubts or queries, do type in the chat box. We have got a question. How can we implement leaf disease by using this technique?
Leaf disease, yeah, leaf disease. It is recently the hottest research area. Okay, leaf diseases. It is images. So how many images you are giving us input to the system? Okay, so I shown only the numerical data set only. Okay, numerical data set, data handling functions only we have discussed in this session. But image handling, so many things available. Okay, that is why matplot. Okay, Seaborn. Okay, you can use the particular libraries. What are all the different functions available? You can use it. Okay, the Gaggle dataset also, normally iris dataset and breast cancer image dataset also already built-in data set available that is accepted by the Python. Okay, but I don't have experience with leaf disease image, but I had experience with iris data set and breast cancer. Okay, so you can feed your own leaf disease data set, and you can get the whatever the things you want to extract from the data set you are expecting, you can get it, okay, with the help of the predefined function which are available in Python. At the same time, if you want to predict the disease affected or anything, means that there you have to work out, okay, you have to feed the rules, corresponding rules, okay, what rules need to process, okay, so that you have to import, then only you can do it. So the mainly the Python code, for that purpose you need to add some code. There is no, okay, fixed thing you can get it. For example, classification algorithm, definitely it will give the result, okay, whatever the result you want, you can get it. At the same time, okay, if you want to do any changes over the existing classification algorithm, that case you have to do the things. Okay, thank you. Next one is, next question, how we can implement traffic detection method in this technique? Yes, okay, we can do the data analysis. Okay, so whatever the numerical data I have discussed in this session, for the simple data set I discussed here, okay, instead of that particular employee data set, you can take the traffic data set. Okay, traffic data set, you can use the trace data set, okay, which is collected from server, okay, the very big server or your college server also, you can take the trace data set. Okay, if we have around 500 system, means we will get reasonable number of records, okay, as a trace data set that can be given to the system. Okay, so that entire data set can be analyzed by using the predefined functions which are available here. At the same time, you can feed into the particular classification or grouping, okay, clustering technique, okay, whatever the algorithm we have, we can feed into the data set, you can get the classification. Usually the traffic detection, so where we have congested, so this case, okay, you can plot the graph, okay, so you can the entire data set also can be represented in the form of graph. Okay, so that case you can easily do that. Okay, so that time you can identify the area where we have the traffic. Okay, so that numbers also we can get it by analyzing for performing the more analysis over the data. Next one is, can you help me to get some data sets related to leaf disease plants? Yes, sir. But the I know one of my friend, she is going to complete now. Okay, she is in synopsis stage in Anna University. Okay, but she have collected 50 images only after visiting the so many agricultural office and direct so many things. Okay, she taken lot of effort, and after that only she have collected only 50 images. By using those 50 images only, she is going to complete her research. Okay, so I think so there is no standard data set for leaf disease. Okay, so you please try to collect the data. Okay, so can you share your contact? You please take my number, okay, contact number, and personally you will ask, I will give her number after getting the getting permission from the person. Okay, so my number is, okay, 9488869712. Okay, separately you please call me, so I will contact. Okay. Yeah, I shared my contact number. Please take it, 9488869712. This is also WhatsApp, my WhatsApp number. You can WhatsApp me. Okay, if you are not getting me, okay, through call, you can WhatsApp me. Okay, thank you. Any other query?
I hope there is no query, sir. So I
Okay,
finally
thank you.
conclude this session by thanking our speaker, Dr. Ganapati sir. And also I want to thank all the participants for spending a quality time here. I hope this session has been very useful to us. We have got a question. Which method is the best one from Shivakumar sir?
Okay, which method, what aspect, whether you are asking about classification or clustering or any feature selection? Analysis of data set. Okay, analysis of data set, you can, whatever the, based on that, you can use the available methods. Okay, there we have visualization and numerical data. Okay, and sorry, statistical analysis, we can do that according to your data. So for example, your input is image, means you can go with the particular visualization, okay, result or analysis, data analysis, whatever the functions available in Cbond, okay, you can use that. Okay, so normal numerical data means you can travel with NumPy. According to the data set, you can choose your analysis method.
Thank you, sir. I hope this session has been very useful to all participants. So this is Sabarishwa signing up this session. We shall see in the next session, if possible. Thank you all.
Thank you. Thank you.
எங்க சொல்ல முடியுது 2 மணி நேரம் உட்கார்ந்தாலும் ஃபுல் முடியல. அப்படியே அவன் உடஞ்ச ஒரு 1/2 மணி நேரம் கூப்பிட்டு சரி
சரி நான்
Sir, Jai Ganesh, sir. Good morning, sir.
Hi, sir. Good morning, sir.
Yes, sir. In few minutes, we will start, sir.
Yeah, sure, sir. I'll be learning. Yeah.
Okay.
A very pleasant good morning to one and all present here. This is the phase 2 session of STTP series on machine learning day 2. I welcome all the participants for this session. I thank our CEO Sri Sai Prakash Liyamuthu sir for arranging this information session, and also I thank AICTE for sponsoring this event. I convey a hearty thanks for our principal Dr. K. Palanikumar sir and our coordinator Dr. B. Sridevi ma'am, Department of CSE Department, and our co-coordinators Jay Chandran sir and Rajlakshmi ma'am. I once again welcome all the participants for this event. We have eminent speakers from various institutions who have been gathered here to share their views and knowledge about this topic. So here we have Mr. Jai Ganesh Suresh, our session speaker. He has done 6.5 years of experience in training domain as freelance, associated with in many MNCs and education institutions. He is currently working as senior lead engineer at HCL Technologies in engineering research and development. He has been a part of 4 FDP programs under the domain artificial intelligence, machine learning, deep learning, and many more. He is the youngest judge of the Smart India Hackathon of 2019, and he has also conducted 100 plus workshops in various reputed colleges and many educational institutions. He has attended various workshops and trainings regarding machine learning, embedded systems, IoT, and artificial intelligence. He has also specialized in the areas like artificial intelligence, robotics, deep learning, machine learning, and many more. So without any delay, we'll welcome our today's speaker. I welcome you, sir.
Yeah, thank you so much, Jailashmi. Thank you so much. Okay. Yes, I think all setups are fine. Yes, okay. So, hi everyone. Uh, so I welcome you all to this webinar about introduction to machine learning and its application. So before I get indulged into the event, I would like to thank to the coordinators and HODs and as well as the person who given the introduction about me. And more than that, I hope that you all are really safe in this quarantine day, because already we all are locked up in tough days, and I hope that you all are really safe in the way of health. Okay, so now you all have got enough introduction about me. Anyway, I would like to take a moment to tell a tiny about me anyway, as a part of my slide. Okay, so here, so this is Jai Ganesh, who is working in HCL Technologies as a senior lead engineer. So my complete working domain is based on artificial intelligence and machine learning and deep learning stuffs. Okay, so now so into the upcoming slides. Yes, a few things about an online class. So I need to tell about this particular term, because we all are not new to this online classes, because for the past 4 to 5 months we all have got enough experience about online classes, obviously, right? There is no doubt in it. But thing here is, when you're in a classroom session, that was a completely different, because we will be in an environment and somebody there will poke us out, and that environment will push us out in order to learn, in order to get indulged into some topic into it. But when you come for online classes, that was completely different, because until unless we give some interesting or something else, we cannot able to learn anything into it. Okay, so because there is a lot of factors when you come for online class to learn something about what I could say in the sense interesting, it might be interesting or knowledge. Can you please list it out, what are the important factors are really important when you come for an online class, so that so you can give your because I would just want my section to be interactive so that if you give some answers through the chat boxes, through that I can able to talk a lot and I can able to get you out. Okay, can you tell me that what are the important factors are really important when you come for online classes? For example, interesting or knowledge, anything else? Can you list it out in a chat box? I'm just observing it here. Okay, any interesting answers from here? Okay, interesting knowledge. Okay, so this way if you take it out, I would tell the primary factors for online class of focus, because focus is a primary factor when you come for online class, because and then only you can able to sit and learn, and you can able to get into that what that slide says, and parallel you will observe what actually I'm coming to say. So I would suggest a focus is a primary factor when you come for an online class. If you all truly accept that a focus is a primary factor, could you please all tell me that what mistake, what error you have found in this particular slide? Can you give me some ideas in a chat box so that I can able to get it out? Okay, can you able to identify any mistakes in the slide? Any mistakes? Few things about online class, any mistakes have you found? So some of them would have found, I guess, because yes, yes, some of them would have got some issues that class, because there is a mistake in a class. Yes, exactly, thank you so much. So when you start observing, when you start giving a focus on the slides, you all observing there is a mistake on this particular slide. It's a very good. So this kind of interaction I would require. Thank you so much. Now I'm getting into the next slide. So artificial intelligence. What this particular term says, artificial intelligence, this is not a new word to us, right? Because we have been heard this particular word for long, but I mean 3 to 4 years we are listening this particular word for many times. Okay, some people would have think about when I say artificial intelligence, some of them would have think about the gadgets, some of them would have think about an applications, some people would have think about the games or some stuffs and all. Some people, maybe some people would have think about the robot has to come in front of them and it has to interact with them, so we are treating a machine as a slave. If you think this way, this is not exactly into the machine learning or artificial intelligence. If you think the earlier way, the gadgets, applications or gaming stuffs, yes, it's truly correct. Of course, that is an artificial intelligence, because artificial intelligence, it might be a machine, it might be hardware or software, whatever it may be, which mimics the human behavior. In simple terms, I could say that instead of using a human effort, if you are using any hardware or software to replace a human effort, that kind of applications, that kind of method, technology, we could call as a artificial intelligence. And I want to take a moment to see about the slide, because in this slide you could notice that, right, AI is a magical want to create the incredible things. If you truly accept that, yes, obviously that is exactly true, because as of now we can able to do a lot of interesting applications in our mobile phone itself. A simple example, Google and Microsoft and Disney are introducing a lots of interesting technologies through this AI, and they are introducing each and every day, they are introducing a new developments in their applications. So obviously AI is a future, AI is like anything. Okay, so now, so this is a movie. Okay, so most of you knows about this movie, I guess, the Terminator. So I hope that you all knows that when this movie came around to the market, almost 1980s. Think about it. In this movie, there's a lot of AI prototypes has been introduced up as a part of movie. So think about it. 1980s, what do you think about? Now only we people are talking about machine learning, deep learning, artificial and everything. So it was like 30 years back, it was like 40 years back, the movie has been released. At that moment they have introduced many things about artificial intelligence, how it is possible. Think about it. So AI is not a new word to us, it's been there for the past 40 to 30 years itself. But now the technology supports us, now the features it supports us to go for the next level. I will tell you why we are talking about machine learning and deep learning for the past 3 to 4 years. Okay, so now this picture what says, in the sense, he is a robot. Okay, he's looking the particular vehicle, whether this vehicle will suit for his democracy or not, I mean for his physique or not. think about it, for his physics, if he try to draw a TVS 50 or cycle, obviously it will not be good for his physics. So that he's looking into the vehicle and he's understanding the vehicle capacity and he's choosing the vehicle. And if you closely observe the same vehicle, the actual vehicle is being occluded by another vehicle. The actual vehicle has been covered by another vehicle. Even though it is been covered by another vehicle, it can able to understand the complete part of an image with the help of a 50% of the actual image. How it is possible? Think about it. Nowadays the image segmentation and identifying the remaining part of an image with the help of a 50% of image is a research paper as of now. Because the 2 months or 3 months back I have read out one news that with the help of a 50% of your fingerprint, we can able to identify the remaining part of a fingerprint. So this is kind of paper is being released and now it is in the real-time development. But at that moment, we don't have any facilities, we don't have any knowledges, but at that moment, they have been talked about this kind of prototype designs. So the AI is not a new word to us. If you all not, if you some people are strange with this movie, and I hope that you all are very familiar with this movie. Yes, exactly. This is indeed a superstar movie. So in this movie, a lot of interesting facts has been introduced, right? Because we all seen it, and the second part, what was different because they have shown some what is that robot zones or something else, but apart from that, object detection and object classification, image classification and voice recognition and language understand and everything, many things. If I started to talk about it, there is a lot of factors has been introduced in this movie. And if you ask me how much of percentage we have been achieved through how have been achieved about AI, in the sense out of 100%, I could say almost 40 to 50% we have achieved. Application wise, real time application wise, I could say 40 to 50% we have achieved. Why am I saying? In the sense, in our mobile phone itself, we have a lot of interesting, right? Face recognition, face detection, human detection, and more than that, what is that? Fingerprint classifications. Many things are there. Okay, so that is the reason I have been shown these two movies. Through that, you will be understanding AI is not a new to us. Okay, obviously. So now I'm getting into the next slide. Yes, so now I have to talk about myths of AI. Before talk about the myths of AI, I would like to show you a video. Okay, just hold a minute. I'll be showing you a video. Yes, here. Just a minute. I will be showing you a video here. Yes. Somebody's in unmute, I guess. Can you please mute yourself if you don't mind? Somebody's in unmute in the group, I guess. Yes. Okay, now I'm playing the video.
that you are watching and the composer of the music. And when the world faces its greatest challenge, I give us the power to take it on together.
Yes. Is it audible at the last instance? Just presenting back. Yes. Yes, thank you so much. Sorry for the interruption because initially I played the video, but I didn't see the option up there. I'm sorry for this. So from the next video, I will be doing the same. Okay, now I'm just coming back to the slide. Yes, the reason for showing this video is AI for all the domains, not specifically into the biotechnology, not specific for the robotics. It's up for all the technologies, all the domains. That is the reason I have been shown this video. And more than that, we all supposed to know about NVIDIA, because without NVIDIA, AMD, and Intel, nothing is possible, because without their technology achievement, our programs or knowledge, nothing will done, nothing is useful. So that is the reason I have been shown this video. I'll be having a many terms to talk, and I'll be telling you in the upcoming slides. So now I need to tell about myths of AI. So what is a myths of AI? Because wherever I goes, most of the people are thinking about AI is everything. With the help of AI we can do everything. So that is not 100% true. So I have mentioned a common myths up here. AI is like human intelligence. Do you all accept that AI is a human intelligence? Obviously it is not, because human intelligence are there to create a artificial intelligence. So obviously human intelligence is always a human intelligence. Artificial intelligence never cross a human intelligence, because the next one is AI learn on its own 100%, and another false myth. Because if you take this one, AI will not learn on its own. We have to give the data based on our application requirements. If you want to develop a particular classification, image classification, you have to give the images. If you want to do some numerical classification, you have to give some numerical data to your machine to understand it. So obviously it will not understand on its own, so that we have to give the input. Through that we have to let our machines learn. So now you all are very clear with these 2 points. And the next one is, we can buy AI to solve all our problem. And another biggest false factor, because we cannot buy AI to solve all our problems. In order to resolve a particular problem, we can buy our AI products. That is true. For example, if you are taking a Google Lens can able to detect an object, and it can able to classify, and it will be telling you what kind of object it is. So if you ask the Google, what is that Google Lens to do for the Google Maps application, mapping applications, obviously that is not possible, because it is meant to achieve a particular task, not for achieving all the tasks. Okay, so we can develop a product to achieve a particular problem. Maybe we can integrate all the products in order to achieve some kind of a problems, not all the problems again. So these are all the common myths I have to talk about whenever I go for some session. So now, machine learning. So what is a machine learning? So exactly what you all are thinking now is correct. Okay, machine is learning is exactly true. Now in some technical way, we could say this: we are letting our machines learn by feeding a lesser amount of inputs. Obviously your machine will not understand. As a human, if you are not seeing a particular object in a future, obviously you will not classify, you will not understand what actually it is. But if I shown the particular object to your in your life first time, so you will be understanding, okay, this is an object of this. Next time if you see the same object, you could have tell about, okay, this is an object of A, this is an object of B. Likewise you could have able to tell. Okay, the same way your machines will not know anything until unless you are learning, you are teaching your machines like anything. Still you're confusing with a point, so I have a next slide. This slide will give you the better understanding what actually I'm talking about. Okay, so now I have a machine learning. So initially the machine learning model will start to learn. First of all, obviously it will start to learn the based on inputs, based on image or numerical data, whatever the based on inputs, it will start learn. And the next one, it will start predicting. For example, I'm just doing some flower classification, rose flower classification. You have given a multiple numbers of roses, and now your machine is completely understandable way to learn a rose. The next time you are showing some other different products, different flower like what is that, lily or something else. Obviously this will say it 10% it looks like a flower, because the leaves, and you will be having some comb, something else. Based on that, it will be predicting out that 10% it looks like some flower, not exactly into the rose. Likewise it will start predicting. So obviously your machine will learn and it will start predicting, and more than that it start improves itself. Obviously through the feedback it will understand the answer which is given by the machine is not a true, and the next moment it will take that feedback, and next moment whenever you are asking the same question, I mean if you are showing the lily, next moment it will show this is object B, I mean this is an object of lily. Likewise it will understand. So machines will do the mistakes and it will take the feedbacks, and the next moment it will improvise its model and it will be giving you the perfect output. So this is what your machine learning actually works, because this is where we are teaching our machines to achieve a specific task. So it learns, it predicts, and parallelly it improves itself. Okay, so the next moment, so what are the inputs are there for the machine learning? Obviously, I could say that image, NLP, sound, and data. So image, most of you knows about it. Simple example, okay, Google Lens is a simple example for image based machine learning models. Your Google Lens is completely based on images. And the next one is natural language processing. Natural language processing is based on a text classifications. Okay, if you have a set of data, so as related to the text, it will classify and it will be telling you what kind of expressions we are expecting from the machines. Example is Google text. Okay, Google text, if you have started to Google compose and Google test, if you have started to type one or two letters or three letters, it will be understanding, it will be giving you the suggestion what kind of letters you are trying to type in the next. Okay, this is a natural language processing. And the next one is sound. Obviously I don't need to say anything, obviously Google voice recognition. And the next one is Google data. So Google data in the sense, in your mobile phone there is a lot amount of data are there. So all the lot amount of data is being organized by your Google products. Okay, because Google Photos and the Google Compose and many things are there, many applications are there on all the application, Google application utilizing your mobile data. Okay, so everything is being organized by the Google products or Microsoft products or whatever it is. Okay, so these are all the classic examples for the inputs for machine learning models. So now, so in the next slide, yes, artificial intelligence is a complete unit. Everybody knows it. Artificial intelligence is a complete unit, and machine learning is a subset of artificial intelligence, whereas deep learning is a subset of machine learning. Now, if you take it out, what is an artificial intelligence? Somebody, if you ask that, what is artificial intelligence, which mimics a human behavior, then what is a part of a machine learning and deep learning does, man? Because artificial is a common part. Okay, machine learning, in simple words, I could say machine learning will can able to achieve many applications. So whatever application you cannot achieve over machine learning, we can able to achieve over deep learning. This is for example I say. Okay, so this is what machine learning and deep learning are parts. Okay, we need to tell what kind of feature extraction, what kind of algorithm to be used in a machine learning. But when you go for deep learning, you nothing need to say. You have to deploy a model. That model will understand whatever it thinks and whatever it understands from the inputs we have given. So this is a complete unit of artificial intelligence, and in this session we're gonna see about machine learning and a glance about a deep learning. Okay, so in next one, yes, now here I have listed out a classic applications of a machine learning. A first one, Google Lens always. So Google Lens, if you are taking your mobile phone and you are looking at some object, and it can classifies and it will tell you what kind of object it is. Because nowadays who is having Android 10 Oreo, and they will be having this kind of Google Lens as a default application in your mobile, I guess. I'm not pretty sure about it. Okay, so Google Lens, most of you nowadays is aware of it. And the next one is Amazon Go. So some of you may know, some of you may not know, Amazon Go is a kind of a technology, is a world's biggest shopping. I mean, advanced technology shopping. So thing here is this kind of a prototype. If you want to go inside into the shopping, you can just get in and you can buy your products, whatever you want, and you just come out automatically. It doesn't require you need to stand in a queue and you need to pay and you have to waste your time, anything. You can just enter and you can just buy your products and you can just come out. That's maximum enough. That's what we call Amazon Go. So some of you may not know, right? I'll show you the video, through that you will be understanding it out. Okay, so the next one is autonomous cars. Obviously, when I say autonomous cars, most of you would have think about Tesla. Obviously, a Tesla is ruling in autonomous cars, and more than that, Mercedes-Benz and Volvo, and more than that, BMW. These fellows are also working on autonomous cars development. And recently, Tesla have introduced two additional autonomic features called, what is that? The parallel parking, and as well as signal classification, or not a signal classification, the lane classification. Okay, if one particular lane is being completely occupied by the some other vehicles, it can able to switch to the another lane. So this kind of two features has been introduced into the Tesla. I mean, just 1 month back I have read it out. Okay, and the next one, Asimo robots. Okay, so Asimo and Navo is a walking humanoid robot. If you want to know about Asimo Navo robot, please get a time and go to YouTube and type Asimo and Navo. You will be come to know a lot of things about, because more than I explain, if you see the video, you will be energized and you will be impressed with the actions of Asimo and Navo robots. That's what I'm saying. Okay, so these kind of applications are familiar for the AI field, and more than that, we have lots of applications are there. Okay, here I have listed out only a few. Okay, now, so if you want to know about Google Amazon Go, I will show you the video. Here I'll show you the video. Yes, here. Just a minute, I'm just presenting it out first. Just presenting a display. Yes, here I'm presenting. Okay, now I'm playing a video. Is it visible? Yes, I'm sharing. Is it visible to everyone now? The screen is visible to everyone, the Amazon Go. Is it visible? Because it is not showing to me anything. Oh gosh. Yes.
Four years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just...
Can someone notify me, like, is it visible? The video which I'm playing, is it visible?
Visible, sir. Visible, sir.
Yes, sir. Thank you so much. Yes.
Go. What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store, so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So, how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout. No, seriously.
Yes. So it is interesting, right? This particular video. So the reason because of this video, think about it. Whenever I just see this video, I'll be thinking only one. So think about it. If the same application has been launched in India, within 2 to 3 days, the complete products will be vanished out because we are so smart, right? The Indian peoples are. Okay, so that is why. So this is Amazon because they have used deep learning technologies, and more than that, computer sensor fusion and computer vision. This kind of technology has been wrapped, and they have introduced this model. And in some countries it has been launched officially, I guess in US, Longmount, and Russia they have launched, I guess. And maybe in India it maybe takes some other times, I guess. Okay, so now it is a part. Okay, it is a classic applications, obviously. Now if I say you that we are using AI applications each and every day, will you people accept that truly? Okay. If I say you that each and every day we are using AI applications, will you accept it? Yes, we must accept it because these are the daily applications which are using in our day-to-day life. The first one is Google Compose. Google Compose, most of you knows about it, right? Because the obviously the professions will come to know if they are taking a Google Compose, and if you're there try to type something else, it will be start suggesting you what kind of text and what kind of sentence you wants to complete without. Okay, now you could have think about, okay, these are the common sentence suggestions. And if you think about what is a regional level communications, region level suggestions, obviously that is also possible, because if you are having a Gmail accounts with the region level communication, obviously that will be giving you the suggestions based on a region level suggestions. That also is possible. It is not exactly into the perfect English words and all. If you are trying to type some letters in terms of Tamil or Telugu or something else, it will be giving you the suggestions based on it. So Google Compose is a kind of a technology. And the next one is Cortana. And most of us having a Microsoft products, and most of us computers will be having the Cortana, and most of us not using it. That is a strategy. That is a tragedy here. Okay, if you wants to utilize a Cortana, because nowadays it has been equipped like anything. Okay, just try to use Cortana and make your system as a more smarter. And the next one is Google recommendation. Now I could say, I could give more word for the Google recommendation. The reason behind of it is, nowadays if you started to type one letter or two letter, it will be giving you the 100% suggestions what actually you're coming to type. Is it sure, right? Because 100%, I hope you all accept that. The reason behind of it is, earlier 5 years before or 2 years before, if you are trying to type one word or two words, obviously that will not give you the perfect suggestions. But nowadays it was completely a different one. Okay, and the next one is Facebook face tagging. Okay, nowadays you could feel, I guess, if you are posting a picture. Okay, now it will be asking you that you want to tag Deepan, you want to tag Akshaya, you want to tag Maunika. Likewise, it will be asking you the suggestion. Think about it. In a future, it will be tagged on its own, and it will be asking us to untag if you don't want a person to be tagged. Who knows, in a future that 100% will happen, because it is understanding the faces of a picture. Because the fellows, whoever your tag, whoever your updater, all the persons will be there in a Facebook already. That is why it is understanding the faces into the next level, and is asking, and it is understanding whether you want to tag this particular person or not. Okay, so the next one is Uber algorithms. Yes, obviously Uber and Ola is into the next level, because two specific algorithm I could address here. First one is weather predictions, and the next one is what is that, demand classification. First one, for example, if you are trying to afford Uber or Ola in the morning time around 8 o'clock to 11 o'clock or 11:30, that is not 100% possible. Am I right? The reason behind of it is what? Because that is a demand. The demand during that time was a completely different. So if you're trying to access Uber or Ola, obviously the prices will be in a next level. And what we will, so why the prices has been getting hiked like anything? Okay, now what we are thinking, the customer, the what is that, the clients will be sitting on the other side and they are increasing the price and everything. But that is not exactly true, because that is understanding based on algorithm called demand classification, and it is increasing the price. And the next one is weather prediction. Now the weather will be the normal, and suddenly it started to rain, or what is that, some cyclone or something happened, automatically based on the particular region, based on a particular weather condition, the prices will get higher because the demand will change. So think about it, these kind of things is not doing by the human, the sitting on another side. It is, everything is happening by controlling by the algorithms which is developed by the Uber. Okay, so now So if you are trying, if you are seeing the Uber or Ola prices is getting high, you have to think in this way, the demand classification or weather predictions. Okay, so the next application is an interesting application. Most of the girls and most of thug life students would have known about it, I guess, because the face transitions, the girl would have known it, right? Big nose and a tongue come out from the mouth, and big ears, and some big ears, some funny ones. Everything is an applications. So that kind of application is been developed by the normal people using the apps, and this particular application is interested by me because the reason is this is giving you the 100% transition, how you will be looking in a younger and how you will be looking in a older. So this kind of transition is really works because in this kind of transitions required each and every pixels to be consolidated, and then only this kind of transition is possible. That is why this particular application made me more interest, and I have been listed it out here. So I have listed out a very few daily used applications here, but more than that, we have a many applications. That is true. Okay, and so the next slide now. So yes, another factor why machine learning is screaming now. As I told you earlier, this machine learning model and this kind of technology is there for the past what is that 40 years itself, but the past 3 to 4 years only we are screaming about machine learning, deep learning. And if you learn about a data scientist, you have a great future. How it is possible, how this transition is happened due to this kind of these 4 points. The first one is a data. Think about it. Earlier, will not have much data. I mean, the Google, Microsoft, if you consider them, they will not be having a much data within them. But nowadays, they are having a data, ample amount of data like anything. Okay, and each and every day they are understanding the data and they are getting the data each and every moment. Because the reason behind of it is a second reason: online. We are we all are being in online at all the times. So nowadays we are not turning off the Wi-Fi. Nowadays we are not turning off the mobile data or anything. Each and every moment a packet of information is being uploaded to the clouds or Google. It is being captured by the Google and Microsoft and some other MNCs, and they are using your data and they are evaluating, I mean, they are, what is that, enhancing their applications. So first is a data. Earlier, 5 years back or 6 years back, we don't have much data. Nowadays, our mobile phone will be having, simple example, nowadays we have a mobile phones. Okay, nowadays the storage is kind of, what is a 64 GB, 32 GB and 128 GB. But 6 years back, if you consider, we'll be having a maximum 2 GB of storage or 3 GB of storage maximum. So what we will doing, we'll not keep all the data in our mobile phones. We'll be transferring all the data to my laptop or something else. But nowadays we are keeping all the data in our mobile phone itself. Each and every day we are visiting to the new places and we are capturing the different places, different faces. So that kind of information is understanding by the Google and is been what is acquiring by the Google and Microsoft products. How they are acquiring? The reason of online, because we are being in online. So MNCs practiced us to be in online at all the times due to the geo and due to the, what is it, broadband called ACT and Reliance or something else. They are they given a lot of opportunity to be in online at all the times because everything is a cost. The next one is
சார்
somebody's in
நான்
unmute.
ஜெயச்சந்திரன் சொல்லிட்டு சென்னை தாம்பரம் சாய்ராம் காலேஜில்
Sir,
பேசுகிறேன் சார்.
somebody's in unmute, I guess.
சிஎஸ்சி
Can you please
டிபார்ட்மெண்ட்டில்
mute?
அசோசியேட் ப்ரொஃபஸராக இருக்கிறேன். ஜெயராமன் இப்போ 12th முடிச்சிருக்கா அப்படிங்களா சார்?
Hello sir, somebody's in unmute, I guess, sir. Yes. So the next one is next one I could talk about a cloud. So now they have got a data. So now their practices to be in online. First one. Okay. Now they have got all the data from our mobile phones. Now they need, so now in our mobile phones we have a 64 GB, 120 GB. That is not a big deal. But they required an ample amount of storage. Okay, ample amount of storage in order to store the data which is being captured by the each and every users. For that they need some other technology, right? So that technology we could say cloud storages. Cloud storages means SSD, solid state drives, with the help of a single NAND tech, because it's completely based on NAND technology. With the help of a 3x3 chip, we can able to store 1 TB and 2 TB of data. Think about it. So now they have got a storage also in order to store ample amount of data, and more than that, in order to process all kind of things in together, we require a processor. Okay, with the help of a single core or dual core, it is not possible. I mean, with the help of a CPU, that is not possible 100%. We require more than that. We require more frequency speed, and we require more number of cores in order to handle this kind of amount of data. That is the game. That is a part we call GPU. GPU in the sense graphical processing unit. So if you are a game users, you will be come to know, because nowadays mobile phone itself, they are providing a specific storage, I mean the specific processor for gaming. So think about it, because we have a more number of cores, we have a more number of frequency speed, with the help of that we can able to process the ample amount of data in a second. So this is a reason why machine learning and deep learning came into the market, and why we are talking about past 3 to 4 years about this kind of technology, because all this kind of technology are joined together to support artificial intelligence. Okay, if somebody asks you now why this kind of when evaluation is happened, we could say these are the listing things. Okay, so the next one is why AI now. Obviously, flood of digital data and increasing in a computational power. Obviously, we have a lot number of digital data. If you want to develop a particular application, we can go to we can capture any kind of data set from online, we can download and we can develop our application, we can sold it out. That is possible. And more than that, we require a computational power. So for that, we have a GPU. Obviously, we can develop and we can sold it to any MNCs like we want. So that is 100% possible. So now if somebody asks you why AI now, we have another reason for that too. Okay, so here now we can get into the little more session. So now I'm saying you think about an apple. So when I say think about an apple, what comes into your mind? Can you please list something in the chat box so that I'll get to know what idea you will be having in your mind. So when I say an apple, what comes into your mind? Can you please list out some ideas? When I say an apple, what comes into your mind? Some people would have think about a fruit. Some people would have think about an iOS. Some people would have think some people would have think about the first what is a Newton or something else. Different ideas. Is obviously a fruit, a phone, anything else, anything else. Any ideas apart from this? A fruit, okay, so common one. A phone is iPhone, obviously. Any ideas apart from this? Any ideas do you have? Okay, so now some people would have think about the Newton, some people would have think about the India's first satellite named called Apple. That was amazing answers. Okay, so now however, whatever if I say, whatever you say, you all will come into the category called these three parameters. Obviously the first one is a red apple, and the next one is a green apple, and obviously the next one is a Apple logo, iPhone logo. Just a minute. So iPhone logo. So now in the on the left we have a red apple, right? On the left we have a red apple. In order to say this is an apple, what are the feature actually we will be extracting from into it in order to say this is an apple? Can you please let out some answers here? In order to say this is an apple, what are the feature you are extracting into it? Okay, the first one obviously a shape. Second one, obviously you could say the color. Okay, what is the next one? Because another particular features is a real important in order to say this is an apple. What isn't that? Just obviously a shape is a really good one. Anything else? Shape. Next one, anything else? Color. And apart from this, because each and every object which I have listed out here will be having a different color and a different shape. Okay, and apart from this, it has some unique feature. So that one we could call it as a texture. Okay, because each and every object, 1 minute. Now the next one we could say this is a texture, color, shape, and the texture, because each and every object will be having its own texture. Through the texture we can able to classify the object into the next level. Okay, so if I ask you, if you ask me that what are the factors you will be extracting from this apple in order to say this is an apple, I could say color, shape, and obviously a texture. Okay, so now this is what the human sees an object, and this is how your machine sees an object. Okay, so array of an informations, I mean your computer sees into the two big matrices. A first 3 column may represents a colors, and another 3 column may represents a shape. The rest of 4 columns may represents a the texture. Okay, this is what your machines will understand. If you ask me the question that is it possible to extract only the color features from an image, if only the shape informations from an image, exactly, that is possible. That is a part we can come up with feature extraction. Okay, the feature extraction is a part where we can extract the informations from an image, because in simple words I could say that your brain is a machine learning. Okay, your brain is a machine learning. It has a many algorithm based on an input you are giving to the brain. It will process and it will be telling that what actually we are looking into it and what actually we are listening into it. Okay, so the feature extraction is your eyes. Okay, you are looking into some object. Okay, so whenever you're seeing an object, we will be seeing a different color, shape, texture. So it is extracting those informations, and those information will be feeding to the machine learning technology, I mean machine learning technique called brain, and it will do the process and it will be giving output. So this is we call a feature extraction technique, and this is we call machine learning. So it's kind of a vision, and it's a kind of a, what is that, a brain. Okay, now I'm just applying only the color image descriptor for the particular object. Now that will be giving you the values which is related to the color image description, color images. I mean the color related values, not related to the text or not related to the shape. Okay, whereas if you apply a texture image descriptor, that will be giving you the only values related to the texture of an object, not related to the shape or color. Now if you ask me the same question, okay, is it possible to understand a different features from the single image? Yes, obviously it is possible, because some of the object will not be much specific to the texture, much specific to the texture or color or something else. At that moment we can extract all the three different features and we can push into the machine learning algorithm, so that it will be understanding a particular object in a next level, so that it will be, your machine learning model will be reaching into the next a process or something else. So obviously a feature extraction technique is much useful when you come for computer vision technologies, because computer vision will be having a multiple technique called, right, OpenCV, and in OpenCV we have a multiple libraries to understand the image in the next level. Okay, so this kind of techniques we are using in a computer vision. And now when you are developing a particular application, we generally encounter with a different type of challenges. So here I have listed out a very specific challenges. The first one I could say this is a background. Okay, now on the left you have object one, on the right you have object one. Okay, now just consider you have a sheep images. Now you have a sheep images, on the left you have 100 images and you have trained your machine. Okay, now you are taking a right images, I mean right image, dog is a right. Now you want to classify whether it is a dog or not. Okay, whether it is a dog or not. Now you are checking, now you are taking, this is a query image. On the right you have a query image, on the left you have a training image. Now you are pushing this query image to your machine learning model and you are asking whether it is a dog or not, whether it is a sheep or not. What it will say? Obviously that will be giving you the false answer 100%. The reason behind of it is because if you closely observe these two pictures, okay, 80% of these two pictures is being occupied by the green color. I mean 85% these two pictures is matches, even though on the left we have a sheep, on the right we have a dog, but your query image will be giving your machine learning model will give you the proper answer called this is a sheep. The reason behind of it is because 80% it matches with the training images. That is why it will say that this is a sheep, this is not a dog. But as a human we can understand it, because we can understand the different features, we can understand the different ideas, so that we could say okay, this is a dog and this is a sheep. But your machine will not understand. So what we have to do in order to avoid this kind of problems, we have to eliminate the background. So that means we have to understand what is a foreground and what is a background. So through that we have to eliminate a background and we have to take only the interested region of our classification model and we have to train it. That means we have to take only the sheep image and we need to train our model, not the backgrounds. We have to eliminate the complete background and we need to train only the foreground images. Nowadays AI camera we are talking about it. What is the meaning of AI camera? AI camera means we have a 2 to 3 cameras into it. Okay, so 2 cameras will be focusing only the background and one specific camera will be focusing only the foreground, so that you could have seen the responses in a picture. So background everything is been background everything is been blurred and only the foreground will be highlighted up. How it is happening? Because your cameras is working on that kind of parts. Okay, it is understanding what is your background and what is your foreground. Through the same way we have to work on machine learning models. We have to eliminate the background and we have to take only the foreground images, only we have to train it out. Okay, so the next one, viewpoints. Okay, so now if you ask me what object it is, I could say this is a chair, obviously. Okay, but of course your machine will get confused due to the viewpoints. So first image, if you given in the sense, obviously your machine will understand, okay, this is a chair. And if you give the third image, it will get confused. It will be saying that 30% or 40% it looks similar to the chair. And if you give the fourth image, and it will say 70% it look like a chair. But obviously this will not 100% sure. The reason because of the viewpoint, because viewpoint will be giving you the different ideas. So some people would have think about it, right? Some people would have said about, like, if you are looking into the straight, you look like a actor Vijay, you look like actor Rajit, and you look like somebody Shahrukh, something as they say. So think about it, because the viewpoints will give you the different change for the human itself. Think about a machine. So when you're training your machine learning model, you have to consider the viewpoint is a primary thing. Okay, viewpoint is also a primary thing. You have to train your machine with the different type of viewpoints. That is very important. And the next one is scale variation. So do you think that you have asked me that scale variation is the biggest part? Obviously, as per the technology, as per the libraries, this is not a big deal, but we must consider. Think about it. Okay, an example I could say, if you go for Taj Mahal or Agra, some people would have taken pictures, right? They are holding the Taj Mahal on the top of their hand. I mean, they are holding the Taj Mahal with the tip of their hands. How it is possible? Due to the scale variations, due to the distances. So this is possible. And in a simple example, in a real-time example, I could say this autonomous car. So for example, you are driving a car is a 180 kilometer per minute. At that moment, it is detecting the human in a size of 3 feet or 4 feet. At that moment, your machine, your model has been adamant, I will not accept this as a human. Think about it, what will happen? The human loss will happen. So the scale variation is not a part, but scale variation is also a challenges to be considered when you deploying a particular model. Okay, and the next one the next very important is occlusions. Occlusion is a very important thing we must consider, because think about it, on the left is a dog, on the right is also a dog. As a human, we can able to understand these two are not a different animal or something else, but your machine will not understand that, because here 100% image is there, and here we have only the 20% of the image is there, and 80% is been occluded by some other objects. Obviously your machine will get confused in this moment. So you could have think about, when you are deploying a model in a real time, how can we handle this kind of problems? Obviously 100% that is not possible to handle. So that we have to take a training data with the more amount of training data. For example, if you want to deploy a product in a real time, if you are using 1,000 images, I could suggest you use 5,000 images. If you are using a 5,000 images, I suggest you go for 10,000 images. Okay, more training data, your machine learning model will be equipped into the next level, because even sometimes your machine learning model also will get, I mean, your machine learning algorithm also will fail if you have a less amount of data set. And if you have a more amount of data set, if you have a poor algorithm, obviously that algorithm also will give you the more support if you have a more amount of data set. Think about it, how the training data set, I mean, how the data set plays a role in a machine learning and the deep learning model. Okay, so this is a what I could come to say when you're talking about occlusions. And now, so the categories. Okay, the categories is a supervised learning and unsupervised learning and the reinforcement learning. Okay, so what is a supervised and what is unsupervised and what is a reinforcement? So before I explain about this kind of categories, I'll be taking you the bit activity. Through that activity, I'll tell you about what is a supervised and what is unsupervised. Okay, so here I'm going for an activity. I hope you all are ready for this activity. Please give me the responses in the chat box so that I can able to take out this activity. Okay, so I'll be telling you that what this activity is about. If I say 100, if I say 101, you all have to say 201. If I say 102, you all have to say 202. I repeat once again. If I say 101, you all have to say 201. If I say 102, you all have to say 202. Is it clear? Shall we go ahead? Yes, here we can go. Yes, 101. Can I get some answers in the chat box? 101. So your answer must be yes, exactly. 201. Superb. So okay, superb. Thank you. Thank you. 102. 102 is exactly. Okay. 116. 116. Yes, 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 yes. Okay. Okay, interesting, interesting. Okay. 132. 132. Exactly true. Okay. 64, 64, 64, 64. Now the question is 64. Oh my God, here it is. Yes. Okay. You people are really smart. Okay. Okay. It's really interesting. Thank you so much. Thank you so much. So now what am I coming to say in the sense for supervised learning? Okay. So I have given you the data along with the labels. I mean, if I say 101, you all have to say 201. If I say 102, you all have to say 202. This data is having a data along with the labels, so that if I ask any questions between these, you could have response in a very precise way. There is no doubt into it. Okay, now when I ask 116 and 132, at that moment I have given only the data, not the labels, but with the help of your algorithm concepts, you are giving your proper answers. That means you have only data, not a labels, but you are understanding, you are preparing your own clusters based on the features I have given, and you are giving the proper answers. This is we call an unsupervised technology. Okay, unsupervised learning. And when I suddenly asked about a 64, some people supposed to be confused, but you people are not get confused, because I thought some of you will give answer as a 264. Okay, so that moment, so I will taking this as an example. Some maximum, some people will get confused as a 264. Think about it, at the next moment they will understand, okay, this is not a 264, I supposed to give a 164. So through this, what am I coming to say in the sense, you have did a mistake. Through the mistake, you are understanding and you are giving the proper answers. That means that means you are taking a feedback of a mistake, and the next moment you are enhancing your model and you will be giving the proper answer. This is we call a reinforcement learning. So this is we call supervised, and supervised is all data along with the labels, and supervised you'll be having a data and not a labels, and reinforcement you will be taking a feedbacks to understand to enhance your model. Okay, I hope you're very clear with this activity. Okay, now I'm getting into the real time. Okay, supervised learning, a simple example is here. On the left, I have a multiple amount of Apple images along with the proper data, along with the proper label, sorry. Okay, now I'm pushing this data and label to my machine learning model. Now my trained model has been completely ready with the data and the labels. Now I'm asking a query image. Now I'm pushing a query image to my model. Okay, at that moment it will classifies and it will be tell you this is an apple. There is no magic into it, right? So if I ask if I ask a banana image as my query image, at that moment it will be get confused and it will be give this is not an apple. And some moment, think about it in another way, if I give a strawberry image, okay, at that moment it will be giving 80% or 60%, it looks similar to the apple. Okay, so but shape matters here. So this is what supervised learning. So here we are giving anything, and your machine learning model is understanding. There is no magic here, I guess. But when you come for unsupervised learning, here I am giving a multiple datas, multiple different datas, but I'm not giving any labels. But your machine learning model getting trained into it, and it will be preparing the different clusters based on the feature it understands. Okay, here it prepared two clusters. So first one is an apple and second one is a mango. If I give any query image, which is related to the apple or mango, it will classifies and it will be telling you that this is a object 1, this is a object B. Likewise, it will classifies and it will be telling you what kind of object it is. Okay, this is we call an unsupervised learning. Now next one is a reinforcement learning. Okay, he is an actor and he is I'm deploying him I'm deploying in some environment, and he is doing some performance. For that performance, he is doing some assessment. Okay, now if you understand it, when the actor is deploying into the environment, he knows actually how he performed. That kind of feedback he is getting as a state. Okay, for that he is earning some assessment, right? That assessment he is earning as a reward. So next moment, with the help of these two datas, with the help of these two feedbacks, when he is deploying into the environment next time, he'll be doing the better one. Okay, so this is we call a reinforcement learning. Through the feedback, it will understand, it will enhance the model, and it will be giving the best performance in the next moment. This is we call a reinforcement learning. Okay, so the next one is, the next slide is steps to achieve a machine learning applications. If I get a time in the last, and I will be explaining it out, because this will be taking a much more time to be explained. And the next one, what is a deep learning? Okay, so a little glance about what is a deep learning. So far we have seen about a machine learning, right? Some machine learning is nothing but we have to tell our machine learning model what kind of feature extraction technique and what kind of algorithm we have to use, and everything we need to tell to our model, and then it will be understanding, it will do some performance. Okay, this is we call machine learning. And what is a deep learning? Okay, it will understand the features, it will understand its own features using the complex hierarchical structure. This complex hierarchical structure, what I mean is a neural network. Okay, we are not specifically tell to our model what feature extraction technique to be used and what is that machine learning model to be used. We are deploying a model with some neurons. Okay, we are giving some inputs, okay, I mean the data set, and we are telling our model this is what you have to understand, and it is understanding a different features from the input we have given, and it will be giving you the classifications. Okay, this is what actually a deep learning model works. Still you're confusing, maybe that this slide will give you the better ideas. Okay, now on the top, machine learning. Okay, we are giving an input. Okay, now we need to tell to the machine learning model what feature extraction technique. For example, here we have used a car, so here specific by seeing the input we can go for shape. Okay, I need to tell shape is a feature extraction technique to be used, and I need to tell what kind of classification model we can go for. So I can go for KNN, or I can go for some logistic regressions. Okay, so I need to tell what classification model I supposed to be used. So with the help of these two inputs, okay, this is what your machine learning model will be working it out. Now you can come to the deep learning model. He is a perfect a legend. Okay, he is a master. We don't need to tell anything to him. I'm just giving input to him. Okay, I'm just deploying a neural network model. Okay, how many neurons, how many hidden layers, and how many output neurons I have to classify, everything I need to give. Apart from this, I need to tell what kind of loss functions, that kind of things are different. Okay, so I need to deploy a neural network model. That alone is enough. Okay, now if I give an input to my deep learning model, it will be understanding a different features more than a human understands, and the more than a machine learning model understands. Okay, so finally it will classifies whether it is a car or not. You could have think about this is a simple example for your understanding I have given. Okay, but behind of a deep learning there is a multiple techniques are there, because activation functions, the back propagation, gradient descent, and Dallas optimization models, many things are there. So through this kind of hyperparameters, your deep learning model, you can tune your deep learning model into the next level. Okay, so this is the reason for what is a machine learning and the deep learning. Okay, now the next slide I can go for current trends. What are the current trends are there? Okay, so in a machine learning model and a deep learning model we have seen about. So what is the current trends is dominating the current world? I could say this is generative adversarial networks. Okay, so before I could explain what is generative adversarial networks, I have one video and have one personality, and he would explain what is generative adversarial networks into the next level. Here I'm presenting a video. Yes. Yeah. Yes, I think you all able to listen audio. If not, please listen the subtitle. Yes.
Hi everybody, and welcome to MIT 6S191, the official introductory course on deep learning taught here at MIT. Deep learning is revolutionizing so many fields, from robotics to medicine and everything in between. You'll learn the fundamentals of this field and how you can build some of these incredible algorithms. In fact, this entire speech and video are not real, and were created using deep learning and artificial intelligence. And in this class, you'll learn how. It has been an honor to speak with you today, and I hope you enjoy the course.
Right.
Hi everybody, and welcome to MIT 6S191.
Hi everybody, and welcome to MIT 6S191, the official introductory course on deep learning taught here at MIT.
It's very interesting, right? So this is what I'm talking about. This is what I'm talking about. What is a generative adversarial network? Obviously, this must be very interesting, right? So whenever you see this video, you could have thinking to the next level, right? If this is possible, because this complete synthesized video is being developed by the MIT, Massachusetts Institute of Technology, and they have introduced one deep learning, what is that, courses. For that deep learning courses, they have prepared this video as an introductory video. For that, they prepared. Think about it. Think about it. If you all thinks about this is possible, everything is possible, right? We can make many things to be possible if generative adversarial network is possible. Now, yes, exactly. The thing you are seeing into the slide is not a fake one. This is a true what actually you are seeing. It's really surprising, right? So on the left, we have a Mona Lisa picture. So it's a great art. And so far we have seen this lady in this picture, and we are using a generative adversarial network technique to make the lady to talk. It's really interesting. She see how a reaction and how she is talking, how she's turning her face, and everything is interesting, right? On the left, okay, on the left, a legend, Albert Einstein, and so far we have seen him, seen in the pictures. Now we are using the same generative adversarial network technique to make him talk. So it's much impressive, right? If it is possible, we maximum what we will be thinking, in the sense we could have used this kind of things in the negative ways we'll be thinking. Okay, if you think that that is whether it has happened anything, yes, exactly. Recently, not recently, 6 months back or 7 months back, when this happened, actually, Italian prime minister, okay, somebody have done this kind of generative adversarial network technology, and in order to make the Italian prime minister as a defamation, they have uploaded a video in a Facebook, and it went to viral like anything, and it has been prepared many controversial around many countries. At that moment, Facebook was stunned, and they have sit for 6 to 7 hours in order to understand whether it is a morphing video, I mean whether it is a morphing video or original video. And after 6 hours to 7 hours, Facebook approached, and Facebook declared that this is a fake video. So that moment, because of even the Facebook, even the Microsoft also get confused in order to understand whether it is a true video or not, because generative adversarial network technique is not using a normal morphing. Normal morphing, what we'll be doing, we'll be taking someone's face, and we'll be taking that faces into this that patches into someone's face. Okay, we'll be applying that patches into someone's face. This is what we'll be doing in a morphing. So we can able to understand when you are deploying the video into the multiple layers. Okay, that moment, it's a fraction of a second, we can able to understand this is a morphing video. But when the generative adversarial networks come into the field, they are taking only the origins of the faces, I mean only the facial landmarks of a faces, and they are applying into the picture. Still you are confusing. You wants to know, are you really curious? Do you have a real curiosity to understand what actually is working? And here I plays a video again. That video will be giving you the answer for your curiosity. See the video.
Fellow scholars, this is 2-minute papers with Caro Joy.
See this video. In this video, if you observe that, I have a training frames. Just a minute. I have a training frames. The person I wants to be more, I mean, I want to prepare the generative adversarial networks. Here I have a driving sequence of someone's face. Okay, someone's face. I'm taking the facial landmarks of the particular original video. I have taken the facial landmarks through my generative adversarial networks technique, and I'm applying that landmarks into the someone's face. Okay, I mean the training frames. Okay, based on the, what is that? Based on the facial landmarks, the synthesized video is been preparing. See here. So driving sequence is through the driving sequence, taking the facial landmarks, and I'm applying onto the different training frames. So through that, the generator will prepare the multiple generator will generate the different video until it satisfies the discriminator video. Okay, so think about it. If you taken only the specific facial landmarks, you can apply that facial landmarks on any training frames. That is not a big deal here. Okay. Okay, see now I will be showing you the part. Okay, I will be showing you the part how it actually works. So see here. So now I have a facial landmarks, I have a generator. So what am I doing in the sense, I'm taking a original image and I'm applying a facial landmarks and I'm embedding it out. Okay, once I embedded, I'm giving it to the generator. Generator will frequently, it will generate the different synthesized video frequencies. I mean the frequent different videos. Now what is happening? If you talk on the top of a video, if you observe, I'll be having a truth video. I mean the ground truth. Ground truth is nothing but the testing video. Okay, that is a actual video. Now I'm comparing the synthesized video which is given by the generator, comparing with the ground truth video, and your discriminator understand, okay, there is a match loss. I mean the loss function between these two is a very less in the sense, and then only your discriminator model will be released the synthesized video. I mean the actual synthesized video. If the realism score is a very less in the sense, again back propagation will approach. Okay, again back propagation will approach. Generator will generate another synthesized video. That synthesized video will be compared with the ground truth video again using the discriminator part, and the realism score is matches 100% or 95% or 98%, and then only discriminator will allow to release a video. This is what actually will be happening. This is a simple part for your understanding I'm explaining. So this is what actually has been happening behind the generative adversarial network techniques. Okay, so I hope you all got understand, you got an idea what actually has been working behind the generative adversarial networks. Okay, so here I'm going back to the slide again. Here I'm going back to the slide. Yes. Okay, the next one is the style GAN workflow, simple workflow I have prepared here. The first one is the real images. So real images, we have a multiple samples, right? So what I'll be doing this is a random input is that facial landmarks, the generator model will prepare multiple samples and I'll be pushing those into my discriminator model. Your discriminator model will be giving the discriminator loss. Based on a loss, we will discriminator what is that part will define whether the synthesized video to be released or not. If the loss is a very much higher, the back propagation will occur again until unless the loss is getting reduced using the gradient descendant function. Okay, this is what actually has been working on the style gun generator. A lot of videos, a lot of codes also you can get through the many GitHub profiles and many repositories out there, right? You can able to get. So this is a kind of a technology which is ruling as of now, and interesting technology too. And what is the second current trends I could talk about? So what is the use of GAN applications? First of all, okay, generating examples for image data. Some people, okay, for example, you're working on some cancers related, I mean what is that, some tumor classifications, that is a new, what is a new tumor, and there is no data set for that. So at that moment you need to prepare a model, you need to prepare a machine learning or deep learning model with the help of this data set, but you don't have a data set. What we have to do, so at that moment we will be using a generative adverse style gun generator to generate a different data set using our limited amount of data set. So for that purposes we'll be using this GAN. And the next one is in order to prepare the human faces, okay, different human faces. Okay, and the next one is reality photographs and the cartoon characters. And nowadays we are seeing a many cartoon characters, right? Earlier that what is that, the Chin Chan and Dora and something, these examples I'm saying, and Mickey Mouse, Papa the Show. This kind of videos, this kind of cartoon characters are created by the style gun generators. Because if the what is a generated picture is real interesting and it has been impressive way, in the sense that kind of pictures will be utilizing into their part, into their motions. Okay, so preparing the cartoon characters and face aging, one applications I have shown you, right? Day by day using applications list. At that moment this face aging is been using, and cloth translation and video predictions. So these are all the classic applications we are using for the generative adversarial networks. And what is the next? And obviously a chatbots, because freaking chatbots wherever you go. So nowadays Swiggy, Zomato and Facebook, and more than that, what, Amazon, Amazon, Flipkart, and wherever you go nowadays, chatbots is a catchy one, because once you gone inside, the chatbots will catch you up. If you have any query, please ask me, because chatbots, if you want to develop your own chatbot, please try to utilize Google Dialogflow. Google Dialogflow, you can prepare your own chatbox, or else you can use IBM chatbots. Okay, IBM chatbots also you can use, but their there will be some agreement policies will be there, I guess. I'm not pretty sure about it. But if you want to develop your own local chatbots, please try to use Google Dialogflow, and you can create your own chatbot. You can sell it to some other local customers too, because nowadays a business is growing up with the help of Google Ads and the Google Dialogflow. Many students itself are doing a business using this Google, I mean, was a digital marketing business using the Google Ads and the Google Dialogflow. Okay, so if you want to deploy your own local chatbot, you can use Google Dialogflow. And chatbots, I don't need to talk about much about it, because you all experienced, you all know and how the technology actually is working is behind many. And what are the remaining current trends are autonomous cars and marketing automations and many optimized hardwares which is using in Bosch and many things. And apart from this, I need to talk about Python. So why Python? Okay, so far we discussed about machine learning and deep learning and current trends called generative adversarial networks, and more than that we discussed about what is that chatbots. And here all behind we are using a programming technology called a Python. So why Python? Obviously many people knows about it. It is easy to use and code effort is less, and more than that it is an open source, and more than that I could say it's a less weight program. Okay, with the help of a KB level of programming you can able to deploy many projects, because libraries are the matters. The library is the reason why we are going for the Python. Okay, and simple explanation I could give, if you want to, whenever we are start learning a programming, obviously we will be starting with the hello world, right? If the printing a hello world is a tragedy one, how can we learn a program? See here in a C programming, in order to print a hello world you have to work much this. In order to print hello world in a Java, you have to create a public class and you have to prevent some void main functions. You have to work on this much level. But when you come for a Python, you all knows, I guess, print hello world. That's much enough. This is what you want to do it, right? That alone you can do it. This is a simple reason why we are using, since it is a less wide, more people are started to work on Python for machine learning and deep learning model, in order to deploy, in order to sell your products to the customers. So that is the reason why we are talking about a Python for machine learning and deep learning technologies. And what is the usage in real life? Many usages. I have listed of a few things here: spam email detections, language translation, image search, and Amazon recommendation. Amazon recommendation is a classic one. You all knows that, I guess. Google News is also, because I was mesmerized. I was mesmerized with the Google News, because I used to read about only the technology and fashion related news. Okay, first 2 to 3 days I used to watch Google News, which is related to these two areas, and after third or fourth day it will be giving you the suggestions one related to these two areas, not related to the other areas. Okay, think about it, because your Google products, your own mobile applications understanding what actually you are interested with and what kind of news and what kind of things you really wants to see, and they're understanding, and they're giving you on the Google calendars and the Google notes and the Google maps, and everything is synthesized together. Okay, if you are experiencing it out, you could understand, because once long back, I guess, I booked a flight. At that moment the flight has been delayed for 1 hour. That 1 hour delay has been scheduled in my calendar, and it is addressing me, your flight has been delayed for 1 hour. Think about it. And it is giving me some suggestions for whether you want to book for Ola or Uber, and it has been navigating to the G maps. These many synthesized these many synthesized network has been happening behind your applications. Okay, so simply I'm explaining because I was mesmerized with this kind of networks. That's what I explained this one. And who is hiring, who is not hiring? Everybody is focusing on machine learning and deep learning engineer, and more than that, data scientist and the data analyst. So obviously there is a lot of openings in this way, and it's time for an action. And if you want to catch me up, this is my contact number and this is my mail ID. If you have, this is my WhatsApp number too. If you have any doubts or queries, you could have drop me as a text up there, and if I free really, I will be giving you the text back. And please drop me a mail if you have any queries or technical related, or if you want to do any projects related. So that way I could have helped you through this. Please take these two up, and you can get me back at any time. And more than that, so this is my AI community. I have been started in Facebook. Please try to go for a Facebook and just start searching AI minds, so you can get me up there, and you can just follow me, and I'll be posting a new updates which is releasing on AI applications. And more than that, if I do any workshops or somewhere else, and if I do any, what is that, developing any products, if you have any doubts, you can post in a AI minds, what is that, a page, and I'll be give you the solutions to it. So what else, I just thought of explaining one real-time application, but as of now my machine is getting stuck up somewhere else. That is what I couldn't able to show you. Sorry for the inconvenience, because somewhere has happened, my TensorFlow is giving some problems. That's what I couldn't able to show that real-time applications, or else I could have shown you up. Okay, anyway, what else, so okay, thank you so much for everyone, so who have been gathered here, for your patience and the responses, and for the queries you've been asked. Thank you so much for everyone. If you have any queries, you can ask me now. Hello. So you could have dropped any questions if you have any now. Yes, I'm getting some. Thank you so much for everyone. Thank you so much. Sorry for the inconvenience. I thought of showing one real-time applications to all my TensorFlow. It gets stuck to somewhere else. That's why I couldn't able to show you. Thank you so much. Yes,
Thank you,
yes,
sir.
yes,
Thanks a
yes.
lot.
Thank you, sir. Thank you so much.
Excellent session, sir.
Thank you so much, sir.
Thank
Thank you
you,
so
sir.
much.
Thank you.
Yes.
Hello, Satish sir. Good afternoon, sir.
கேக்குதா சார்?
கேக்குது சார். சார் ஸ்க்ரீன் ஷேர் பண்ணுறீங்களா சார்? செக் பண்ணிக்கலாங்க சார்.
தெரியுதா சார்?
ஓகே சார், விசிபிள் சார். தெரியுது சார். இன்னும் ஒரு 5-4 மினிட்ஸ் வெயிட் பண்ணுவோம் சார். பார்ட்டிசிபென்ட்ஸ் வந்துட்டு இருக்காங்க சார். ஸ்டார்ட் பண்ணிடலாம் சார்.
Good afternoon, everyone. It's the third phase of today's session. This session topic is on image classification using machine learning tools, which is going to be presented by the speaker, Dr. V. Satish Kumar sir. I welcome all the professors and doctorates from various institutions for your presence in this session. I once again thank our college management and our CEO, Sri Sai Prakash Leomuthu sir, for arranging this STTP series. And also, I thank AICTE for sponsoring this event. So, without further ado, we will turn over our time to our speaker for today's session, Dr. Satish Kumar sir. Dr. Satish Kumar sir is an assistant professor from Department of Electronics Engineering, MIT campus, Anna University, Chennai. He has over 7+ years of experience in teaching, and his research interest includes AI, ML, computer vision, and so on. Moreover, he has published nearly 55 international research publications and 1 patent. We are honored to have you, sir. So I request our speaker, Dr. Satish Kumar sir, to take over the session. Please, sir.
Thank you very much for your introduction. So, very good afternoon to all the participants. So, whether the screen is visible?
Yes, sir, it is visible.
Thank you. So, today I am going to talk about image classification using machine learning techniques. So, first let us start with a basic introduction about an artificial intelligence system. So, what do you mean by an artificial intelligence system? So, we are going to have a CPU, and CPU is going to be programmed. So, this program is going to do certain things, like it is going to do sensing, reasoning, act to a particular situation and adapt to a particular situation. So that is what we try to do in a program. So if a program normally executes and gives a result, it is not that much intelligent enough. So if a program has the sensing capability, reasoning capability, act and adapt to a situation, then we say a program is going to be something related to an artificial intelligence system. So this thing you have to remember. So an artificial intelligence system is nothing but a CPU which is going to execute a program, and this program is going to do certain things like sensing. Sensing in the sense we try to take some input parameters through sensors, do the reasoning, why the data is like that and how to modify it. So certain things we try to do, we try to modify in our environment and adapt it to a situation. So this in artificial intelligence system, we have a major subset called as machine learning. So in machine learning, what we do is we try to execute the algorithm or a program multiple number of times with more data into it. As I expose more and more data into my program, it gains a lot of experience. Once it learns all these experiences, then it can able to make some real-time predictions, fast predictions. It can be able to do that. So, and again in machine learning, we have another subset called as deep learning. So again, we try to run a code which is going to be using a huge amount of data and do the processing. But here the program is going to be in terms of a neural network. So we try to execute a neural network. Thereby, the machine gains the experience. So thereby, it tries to predict what will be the outcome in the near future. So we have different applications. In artificial intelligence system. So we can use it in natural language processing, in machine translations, social network analysis, robotics, Internet of Things, video and image analytics, audio analytics, virtual personal assistants. So I'm going to concentrate much about this image analytics part. So here we will be trying to use more image processing scenario and how to incorporate image classification using an artificial intelligence system. So in order to understand that, let me go in with some basics of the image. So image is nothing but a two-dimensional information. So this two-dimensional information is represented as a fundamental element by a name called as pixel. So we can combine different pixels to form an image, or in other words, what we can say is we can divide the image into small segments. Thereby, I can reach to a very small element which is called as a pixel. So this pixel can be of two types. It can be a color pixel or it can be a grayscale pixel, or you can say it as an intensity pixel. So as I say, a grayscale or color, so it is easily understood by a human being. But now the processing element is our CPU. So CPU needs to understand. So in order for my CPU to understand this color information or grayscale information, I need to provide it in terms of a number. So we try to put some coding scheme into place. So for example, if I use a 0, it represents a black color. If I use 255, it represents a white color. By changing this value between 0 to 255, I can get different shades of black and white. So here we try to represent the colors in terms of a number so that the machine can able to understand. Same way in case of a color pixel, I have fundamental 3 colors, red, green and blue. So again, I need to fix some scales for this red, green and blue. So we try to take a value between 0 to 255. So here 0 represents absence of a color, whereas 255 represents the purity of a color. So what do you mean by purity? Purity in the sense each color can be represented using their wavelengths. For example, if I have a red color, it is represented by a wavelength of 650 nanometers. Same way, if I have a green color, it is represented by 530 nanometers. So blue, it will be in terms of 400 nanometers. So each color has its wavelength. If I have a very, very narrow spectrum, if I have a very, very short band of wavelengths, then we say it is a purest form of a color. As the band increases, as the narrow band becomes wide band, then many other wavelengths gets added to my input color. Thereby, the purity of a color is lost. So we try to represent this scale in terms of the purity. So 0 represents absence of a color, whereas 255 represents the purest form of a color. So in case of red, green and blue, again we try to fix this 0 to 255 as a scale. So why do we need to fix this as 0 to 255? Why can't I take it as 0 to 500? Or why can't I take it as 0 to 1000 or 0 to 10,000? Why it is some odd number 255? Because we are going to consider a 8-bit CPU. So here I can have up to 2 power 8 combinations. So maximum I can get 256 combinations. So we are going to use 256 different shades of grayscales. Same way, 256 different shades of red, 256 different shades of green, 256 different shades of blue color. So since I am going to consider it as an 8-bit CPU, we can code our color in terms of an 8-bit binary bit pattern. And the next thing which we need to discuss about an image is how to go to a particular location and access a particular pixel. So whenever we do some image processing application, we need to go to our region of interest, and then we need to apply our algorithms in that region of interest. So I need to go to a particular location and then I need to do some modification. So in order to understand that, we need to know about the coordinate system. So usually the image is represented by width and height. In matrix format, it will be row versus column, but here it is width and height information. So which means in mathematical term, it is column comma row. So this, if I want to access a particular pixel, if I want to access this first pixel, then I need to go to a coordinate 0, 0. So width is 0 and height is also 0. So 0, 0. If I want to go to this pixel, then the width is 3 and height is 4. So same way, I need to go to each and every pixel, or I need to go to a particular region and I need to do some modifications. So here I'm going to talk about the image classification using Python programming. So I will show a demonstration of how to implement a program in Python environment. So for that, since Python is 0 in text, here I have tried to show an image as a starting coordinate as 0, 0. do lot of effects like blurring an image, sharpening an image, identify the edges, identify the shapes, texture. So a lot of things can be done using this convolution operation. What do you mean by this convolution operation? Here first I take an image, it is represented as a matrix, and I take a small matrix. So here the red color is indicated as a small matrix. Here I have taken 3 by 3 kernel. So this small matrix is called as a kernel. So this kernel is placed on top of your image and then do pixel by pixel multiplication and then add all the values. So for example, if I put my kernel on top of the image, so in this region, so let us assume my kernel value is this one and the image matrix value is this in that location, then I do multiplication. Minus 1 into 93, minus 93, then 0 into 139, 0, 1 into 101, 101, minus 2 into 26, minus 52. So like that I do pixel by pixel multiplication with the filter values, then add all the values to get a single value. So this single value will be used to replace this center pixel value of my image. Then what I do, I move this kernel towards right by 1 position. Then again I perform multiply and add. Again I get a single value. Now instead of 196, I try to replace it with the new value. So like that I try to do it from top left to right and go from top to bottom. So if I do that, then if I apply this kernel, it can give a blurring effect. If I change these values, it can give some other effect. It can be a sharpened image, or it can be the edge director image, or I can extract the color information, or I can extract the shape information or texture information. So a lot of information can be gathered just by changing this kernel values. So let me show the implementation here. So here I have taken this kernel. So this kernel is placed on top of this image matrix. Then I do multiplication and add. So you can see here I get an output. So this is a convoluted matrix output or convolution matrix output. So this convolution matrix is also called as a feature map. So feature map, in the sense the features are being extracted by the kernel on an image. If I change this kernel, then I will get a different feature map. Same way, if I have 10 different kernels, I can get 10 different features from a same image. If I use 100 different kernels, then I can get 100 different features from the same image. So as I increase the number of kernels, I can extract more and more information from an image. So if I have more and more information, then our machine can able to make a right prediction. If I have less information regarding the image, then my machine is more prone to be giving some wrong results or wrong predictions. But again, the problem is as I increase the number of kernels, the computation time is going to be high. If my computation time is high, then for real-time applications, the processing itself will take some time. So it will not give the output in real time. So it will be something like a delayed version of your output. So in order to reduce that, we need to optimize the number of kernels which we use in our application. So this process is called as a convolution operation. And the output which we get is nothing but your feature maps, not convolution matrix. Now let me move to our actual topic, which is nothing but your image classification and machine learning. So what do you mean by image classification? So we are going to classify an image. So if I show you this image, then I try to give you certain set of labels like cat, cow, dog, horse, wolf. Then I want you to pick any of this label which is more suitable for this image. So basically we need to see what information is there in an image, and I need to identify a proper label for that image. So always our image classification needs to work with predefined set of categories. or labels. So I should work with finite number of labels. I should not work with infinite number of labels. Then my machine will not be able to provide a proper output. So we should work with a finite number of labels. For example, here I have given some 5 categories. So out of these 5 categories, our machine has to pick a suitable label for this image. So in that case, our machine can do 2 things. One is it can pick the most apt label and it can assign that label to this image. And the second option is our machine, instead of giving a single label, it can give something related to a probability score. So it can say something, dog is 95%, wolf is 55%, cat is 50%. Are being given by our machine, then the machine can select the label with the highest probability and assign it to our image. So this process is called as an image classification process. So here, even though this looks very simple, it has a lot of challenges involved in this image classification operation. So for example, here I show you 2 images, one of cat and another of dog. So it is very easy for a human being to identify it as a cat or a dog. But when I give the same image to our machine is nothing but a CPU. So I need to convert this image into a matrix like this. Then from this matrix, our machine or our CPU should make the predictions. Then it becomes challenging. Because our machine is going to work only with the data. So it has to make all the predictions with respect to the matrix given to it. So with that, it needs to make a prediction. So that is the challenge involved in a machine learning algorithm. And still we have more challenges. So one such challenge is your orientation or camera viewpoint challenge. For example, here I have shown 4 images of a Raspberry Pi board. So all are same object, but it looks different. Why? Because it is captured under different camera viewpoints. So for example, if I have an object, I can move my camera around the object and I can take a photo. So in each angle, I will see the object differently. Or else, I can have a fixed camera, I can orient the object in different directions. Then also the object will look different. So in this case, the matrix which I get out of these images will be very different. So this is again a challenge, because for a single object, if I have a single matrix, then it is very easy for my machine to make a prediction. But for a single object, I'm getting many number of or numerous matrices. Then it has to work with all this data to make a right prediction. So again, this is a challenge. Next challenge is something related to the size of the object. So I can have the object of different sizes. For example, here I have a coffee cup, but all the coffee cups are not same. Its capacity is changing, so the size of the coffee cup is also changing. So if I convert this into a matrix, each coffee cup will have a different matrix. Or else, in other words, is I can take a close-up shot of an object, or I can take a long shot of an object. Then also the matrix will look different. So this is the third challenge involved in your machine learning algorithm. Fourth challenge is nothing but your deformation. So some objects can deform in their shape. So if it deforms also, still it is the same object. For example, if I take an eraser. So when we purchase an eraser, it will look different. As I start using it, it will change its shape. So, but still it is the same object, eraser. So this also results in the change in your matrix values. So our algorithm should also work with this deformation, object deformation. Then the next challenge involved is your partial occlusion. So partial occlusion is something related to an object hidden under some other object. The the object is that, for example, here I have shown two images. So in one image, we can see a dog clearly. In another image, again I can see a dog, but it is partially hidden under some other object. But as a human being, I can easily say that in both images I have dog. But when I convert these images into matrix, I will get two very distinct matrices. So that is the challenge involved in your partial uploaded images. Next one is related to your lighting condition, illumination variation. So here the objects is captured under different lighting conditions, but it is still the same object, but it is captured under different lighting conditions. Again, if I convert it into a matrix, the matrix will look completely different. And the final challenge involved is your intra-class variations. So in intra-class variations, I have something here, object chair, but the chairs are of different sizes, different geometry, different color, different texture, but all belong to a common category called as chair. So I can have an intra-class variations. So this also will result in different matrix values. So this, all these challenges, it has to be taken into your machine learning algorithm for our final prediction to be more precise. So the challenges involved are, first one is your semantic gap. So semantic gap is nothing but how a human being perceives the data is completely different from how a machine is going to perceive the data. So machine is going to work completely with the numbers. From numbers, it has to make a prediction. So that is the first challenge. Second challenge is related to your viewpoint variation. So I can take a photo of an object from different angles, or I can orient the object in different angles. So thereby I get different matrix in different angles. Third challenge involved is your scale variation. So the objects can be of different size, or I can take a photo of an object very close by or very far away. So that will also result in different matrices. Fourth challenge is deformation. The objects can deform, thereby the matrix also changes. Fifth one is related to partial occlusion. The object is hidden under some other object. Sixth one is related to your lighting condition. So if I capture an object in sunlight, it will look different. If we capture under tube light, it will look different. If we capture it under sodium lamp, it will look different. It will look different in the sense the matrix which I get from the image is going to be something different. And the final challenge involved is your intra-class variation, where I have a common category, but it has subdivision of category, subdivision like different textures, different geometry, different color objects can be there. So these are some of the challenges involved in your image classification when I try to do it using machine learning algorithm. So now let us try to see what are the different types of machine learning algorithm. As I said earlier, machine learning algorithm is nothing but we are going to write a program and we are going to expose the program with large number of data so that the experiences by running the program is increased. If my experiences is more, then my machine can make a right prediction in the future. So here I have three major types of machine learning algorithms: supervised, unsupervised, and semi-supervised. In supervised learning, what we try to do is we will be having an image that is data, and we will be having the ground truth value, that is the labels associated with the data. So if I have the data and the labels, using this data and labels, I can train my machine. I can teach my machine. So once the teaching is done, then I can evaluate my machine. So this process is called as a supervised learning algorithm. So in supervised learning algorithm, one thing you have to remember is I should have the ground truth value, which means the label associated with the data should be known. So why I should know this? Because if my machine makes a wrong prediction, then I can correct it. When I can correct it, if I know the ground truth value, then only I can correct my machine. If I don't know the ground truth value, then I would not be able to correct the mission. So I should know the actual label of that image. So I try to ask a machine, what is this image? It will make a prediction. If it is a right prediction, no problem. If it's a wrong prediction, then I try to correct it. So this process is called as a supervised learning algorithm. In testing phase, we just evaluate the machine. There is no correction involved. If my machine makes a wrong prediction, we will not do anything. We will just make a score. Out of 100 images, how many images my machine has made a right predictions. So this is called as a supervised learning algorithm. So we have numerous supervised learning algorithms like logistic regression, support vector machine, random forest. So today I will try to discuss about three such algorithms: logistic regression, support vector machine, and ANN. So for example, here I have an image. In an image, I can use the pixel intensities as it is. But if I use the pixel intensities, it will take more time to do the process. So instead of that, what we do is we take an image, we try to extract the features from an image. For example, here I have 6 images. In 6 images, I try to extract the color information. So mu stands for mean value, sigma stands for standard deviation value. So R, G, and B are the color channels. So I try to extract the mean value of red, green, and blue channels. Same way, standard deviation of red, green, and blue channels. So instead of giving my image as an input to our machine learning algorithm, what we do is we give the extracted features as an input to our machine learning algorithm. So thereby it can perform at a faster rate and it can give a result at a faster rate. I can also use the direct pixel values to our machine learning algorithm, but the computation time will be a little bit high. So instead of that, we always try to use the feature extraction process. Feature extraction process is something like extracting the features from the image and using the features for teaching our machine, for testing our machine. So here you can see that. So this feature is called as a feature vector. Here I have 6 elements, so it is called as a 6-dimension feature vector. So this 6-dimension feature vector is extracted from an image which has a label of cat. So this cat is a ground truth value of that image. Same way, second, I have another feature vector with the 6-dimension. 6 dimension is 6 elements. Again, its ground truth value is cat. Same way, I have another cat feature vector. Then I have 3 subsequent dog feature vectors. So I try to use this data for training purpose, for teaching our machine. So I try to show this feature vector to our machine and ask the machine to make a prediction. It will make a prediction. So for example, let us take it is making a prediction cat. Then the predicted value is matching with the ground truth value. So thereby there is no loss. My feature vector is predicted as dog, but the actual ground truth value is cat. There is between your predicted and the, so thereby I need to correct our machine. Our machine learning algorithm. So in case of testing, feature vector and ask the machine to make a prediction. So if it makes a right prediction, we put 1. If it makes a wrong prediction, we put it as 0. Finally, take the total count of how many predictions our machine has made. Correct. Second type of machine learning algorithm is an unsupervised learning algorithm. So here in unsupervised learning algorithm, again we extract the from the image, but here we don't have a ground truth value. So that is the difference between supervised learning and semi-unsupervised learning algorithm. So here I have only the feature vectors. I don't have the ground truth value. So if my machine makes a wrong prediction, I will not be able to correct it since I don't know the ground truth value. So here one thing our machine can do is, based upon this feature vector, it can find the similarity. Based upon the similarity, it can group the feature vectors and it can say that this group is going to have similar characteristics. So based upon the feature vector, the similarity will be identified. Based on the similarity, grouping will be performed. Thereby classification will happen. So this type of process is called as an unsupervised learning algorithm. So here I have different algorithms like PCA. So we have a lot of algorithms that are unsupervised learning algorithms. Then we have another category called a semi-supervised algorithm. In semi-supervised, few feature vectors will have the ground truth value, whereas few vectors will not have the ground truth value. In that case, we use the feature vectors with ground truth value to predict the unlabeled feature vectors. So this technique is semi-supervised learning, and this is not widely used. Often used algorithms are supervised as well as unsupervised learning algorithms. Now we come to the important steps in your machine learning algorithm. So it involves 5 different steps. First step, collection of data set. So this is the very, very important step in your machine learning algorithm. So data set collection. So as I said earlier, our algorithm should have lot of experience. How it can get lot of experience? By exposing more amount of data. So our data set should have more number of images. It should have more number of images, and also it should have variety in the images. So that is also very variety in the sense I should have the image captured different lighting, different orientations, different scale variation, different uploaded images, class variation. So whatever the challenges specified earlier, all this things should be included in our data set. Then only our machine learning algorithm can perform better. So 2 important things you need to take into account is I should have more number of data, and also I should have more variety in my data. So that is very important. So variety in the sense I should have the image with different lighting conditions, different deformations, different uploaded images, intra-class variation. So whatever challenges I specified earlier, all these challenges should be incorporated into your data set. Then only in a real-time scenario, our machine can able to make a right prediction. So once I collect a data set, a very good data set, then I need to divide this data set into 2 important categories. One is training data and testing data. So training data is for teaching our machine. Testing data is for evaluating our machine. So I have 2 phases called as training as well as testing. So in order to do training and testing, I split the data into training data and testing data. So here different research groups, they divide the data differently. So some research groups works with 66.7% for training, 33.3% for testing. Some groups work with 75, 80, 20, 90, 10. Again, it depends upon your application. So based on application, you have to select this data split ratio. So when you try with the different data split ratios, a certain data ratio can be better, then you can stick with it. Like an iterative process. You have to change different data split ratios. So each data split ratio is going to work better. And as I said earlier, I can use the pixels for my machine learning algorithm, but the amount of time taken by our machine learning algorithm to execute the program. So in order to avoid the use, we do feature extraction process. In feature extraction process, we can extract the information, texture information, shape information. So a lot of information can be extracted, and this extracted features can be used for training as well as testing. So this is again another important step in machine learning, feature extraction. So feature extraction reduces the computation time. So we can get a satisfactory with computation time. Once I extract all the features, I can use these features for training our machine. So training in the sense, I expose this features to our machine to make a prediction. If it makes a right prediction, or if it makes a correct it. Is power, I can expose the test data to our machine and try to put the score, how much accurately it is predicting, or how much accurately it is trying to get the result. So these are the 5 important steps involved in our machine learning algorithm. So now let me discuss about machine learning algorithm called as K nearest neighbor algorithm. So K nearest neighbor, from the name itself you can say that I try to see my nearest neighbor. If my nearest neighbor is cat, then I also should be a cat. So that is the assumption which we try to make here. So I try to see my closest similarity. Based upon my similarity, I try to assign the labels. So here this K stands for how many such closest neighbor I am going to consider. If I put 1, then I take the very, very closest neighbor. If his label is cat, then I am also cat. Or if I take K value to be 3, then I take 3 closest neighbors. So top 3 closest neighbors. In that case, what I do, I try to pick the label based upon the voting scheme. If 2 votes say one category A, 1 vote says category B, then I select the label A for the new image. So here, in order to identify the nearest neighbor, we use the distance matrix. If I have 2 points, I can find the distance between the 2 points. If the 2 points coincide at the same position, what happens? The distance becomes 0. If the 2 points are separate or in a large distance, then I have a distance value. So I try to find the distance between the 2 feature vectors. If the distance is more, then we say it is dissimilar items. If the distance is minimum or 0, then we say it is identical. So we can use different distance metrics to make a prediction in this algorithm. So one such distance matrix is your Euclidean distance matrix. So this is the mathematical equation. So D stands for distance. I take 2 feature vectors, P and Q. So P is one feature vector, Q is another feature vector. I try to find the distance between P and Q. So how to find it? For example, if I take P is equal to P0, P1. So for simplicity, I take only 2 elements in my feature vector P. Same way, Q is equal to Q0, Q1. So only 2 elements in our Q. Then how to find the similarity between these two? It is Q0 minus P0 whole square plus Q1 minus P1 whole square. So if I do this, I will get a value. So if this value, let us assume, let us take it as D. This value is D. If this D value is very close to 0, approximately equal to 0, then P and Q are similar in nature. If D is very large, then I have P and Q are dissimilar items. So just by seeing the distance value between 2 feature vectors, I can able to identify whether the image has similar content or dissimilar content. So this method is called as a Euclidean distance matrix. Similarly, I have different distance metrics like Manhattan distance, chi-square distance. So a lot of distance metrics is there. So you can make use of this distance matrix in your algorithm. So let me explain it with an example. So here I am going to do a flower classification. So let us take 3 flowers. So here I have sunflower. So this is daisy, and this is pansies. So I have about 12 images for training, and I have 4 images per category. For example, sunflower I had 4 images, daisy I had 4 images, pansies I had 4 images. Now I'm going to extract the features from this image. What features I'm going to extract? I'm going to extract two features. One is size of the petal and another one is the lightness of the petal. What is the petal size? So that is my first parameter. Second parameter is the lightness, whether I have a light colored petal or dark colored petal. So I try to extract two features. So based upon these two features, I plot this graph. Now I have shown this data to our machine. It has learned. So I'm assuming that the training phase is over. Now it knows, now our machine knows that if I have a petal size this much, if I have a lightness parameter this much, then this should be Kansas. Same way, if I have a petal size of this size and lightness of this value, then it should be a sunflower. So like that it does learn. So now what we do is we try to take a new image. So here I have a new image, calculate, again extract the features. Here I have size of the petal is coming here and lightness of the petal is coming here. Now I am going to assume my k value to be 1. So which means I need to take the very closest neighbor I should take. So how to find the closest neighbor? Here I have, let us assume this as a point. So this is one point and this is another point. This is another point. So like that each image I am going to consider it as a point. Then I can find the distance between the 2 points. So find the distance between the 2 points. Find the distance between these 2 points. Find the distance between these 2 points. So likewise, you find the distance between the two images. Then identify the distance which is minimum. So here, the minimum distance. Here, the minimum distance is this. So what is this label? This label is Daisy. So this new image will be assigned a label Daisy. So that is how our k nearest neighbor algorithm is going to work. So again, let us discuss it. Then another example. Here I take another image. So this is a new image. So here it has something related to size of this petal and lightness of the petal. Now instead of k value 1, I am going to take k value as 3. So in which I am going to take the top 3 lowest distance value images. So one option says it is Daisy, 2 options says it is sunflower. Then what our machine will do, it will pick the label with the highest number of rows. Here I have sunflower with the highest number of rows. So the image will be assigned with the label of sunflower. So what if I have a k value equal to 2? So if both the option says it is Daisy or both the option says it is sunflower, no problem. If one option says it is Daisy and one option says it is sunflower, again there is a confusion for our machine. So what we do is we would avoid this even number of k's. We always use k value to be odd. So if I select k value to be odd, what will happen? Always I will have a winner. Always I will have a winner. Then my machine can easily make a prediction. If I have even value of k, then there is a chance that 50-50 can go to both the labels. Then there is a confusion in our machine. So we need to avoid the k value of even numbers. We always should have a k value of odd numbers. And again, another interesting thing is here, if I put k value 1, it can give a certain accuracy. Same way, k value 3 can give a certain accuracy. So which k value will give me more accuracy? Again, there is a question mark. So here the k is a iterative method or it is a tunable parameter. It's a hyperparameter. It's called as a hyperparameter. And same way, instead of using Euclidean distance, if I use Manhattan distance, it can give a better accuracy. Instead of using Manhattan distance, if I use chi-square distance, it may give better accuracy. So how to identify it? Again, that parameter is tunable parameter. So in order to do that, in order to identify these hyperparameters, what we do is we take the training data, divide the training data into 2 categories. One is training data, another one is validation data. So this validation data is used for identifying which value of k gives me a better result. or which distance matrix is going to give me a better accuracy. So this validation data is acting like a dummy test data. So what we do, initially we take the data set, divide it into training data, test data. In training data, again I am going to divide it into training data and validation data. So here the validation data is used for this hyperparameter tuning purpose in order to identify which value of k, which distance metric is going to give me a better accuracy. I use this validation data. Once I identify the hyperparameters, then I need to retrain my machine with the best value of hyperparameter so that my machine has learned to a greater extent so that it can make a higher accuracy when it is exposed to a test data. So this algorithm is called the k nearest neighbor algorithm. So next algorithm which I am going to discuss is k means clustering algorithm. So here previous case k nearest neighbor algorithm is based upon your supervised learning because the data is having their ground truth values. If I have to work with the data without ground truth values, then what I can do is I can go with this k means clustering algorithm. So here you can easily, from the name itself, you can identify that clustering. Clustering means grouping. Means each cluster is going to have a mean value, or it is going to have a centroid value. K again stands for number of clusters. How many clusters or how many groupings I should have. So for example, let us have some grouping like this. I take 2 more data points. I take 1 more data point. It comes some value. Now what I do, I check the distance between this data point to the centroid of this blue cluster. Same way, check the distance between the data point to the centroid of this green, distance between the point to the centroid of the red cluster. So which distance? This distance is small. So what I do, I form a new cluster combining this. Once I form this, my centroid is changed. So now my centroid is changed to this position. So when a new data point comes, what I do, I compare this new data point with the centroid of this cluster. And again, compare it with this one, again compare it with this one. So again, let us assume this is closer. So it becomes part of this cluster. Again, I need to define a new centroid. So this type of algorithm is called as a k-means clustering algorithm. So it is used for unsupervised learning algorithm. So if I have only the data or the ground truth values, then I can group the similar data items to form clusters or groups. Third such algorithm which I am going to discuss is your support vector measure. So if I have a data point, something like this, if I want to categorize this or if I want to classify this, what I can do, I can easily draw a line. So the point above this line can be considered as one category. The point below this line can be considered as another category. Same way, if I have a grouping like this, again I can draw a line to separate out the data. So this is called as a linearly separable process. If I have a data which can be linearly separated by drawing a line or by drawing a plane, if I could be able to separate out the data, it is called as a linearly separable data. So such algorithm is called as a support vector. So if I have a data something like this, I have 2 data points on the top left as well as bottom right. The red data points on the top right and bottom left. Then how to divide it? Here I will not be able to put a linear line to separate out the data. Here I have to have something like a non-linear function. So I have to have something like this non-linear function so that outside this boundary I have blue data points, inside this boundary I have red data points. So this is class A, this is class B. So I should have a non-linear boundary to separate out the data. So this can be achieved by your non-linear support vector measure. So how this is possible? So before moving on to that, we will try to discuss this linear SVM. So as I said earlier, if I have data points like this, I can draw a line in this way or in this way or in this way. So in all 3 cases, my blue data points and red data points are becoming separate. But which is optimal? So this third plot C is an optimum value because here I have maximum margin of separation between the support vectors. So these points are called as support vectors. So I have margin of separation is very large between the blue data points and the red data points. Whereas here, if I see, the margin of separation is very small for blue data points, whereas it is large for red data points. Same way here, the margin of separation is very less for red data points, whereas it is large for your blue data points. So I should have equally margin of separation for both the classes. Then such type of classification is better. So this is in case of a linearly separable data. If I have a data, something like this, which is non-linearly separable. So here I have to define a non-linear boundary. So for example, if I have a data point like this, then I have to define a non-linear data boundary like this. So inside this I have red data point, outside this boundary I have blue data points. So here I can put something like this non-linear boundary. So that inside this I have blue data point and outside I have red data point. So here I have defined a non-linear boundary. So in order to do that in SPM, what we do is we introduce a trick called as kernel trick. So in kernel trick, for example, here I take 4 data points A, B, C, D, which is not linearly separable. If I am not able to fit a line so that I can separate this A, B, C, D, what I do is I project this data points to the next higher dimension. And in the next higher dimension, I try to see whether I can put a line to separate out the data. If it is not so, then again I project the data from that second dimension to the third dimension. So like that I keep on continuing until I find a line to separate out the data. So what do I mean by projecting a data point from lower dimension to higher dimension? So for example, here I take 4 data points A, B, C, D. So in order to project this data point to next higher dimension, what I do, I take some function K of A with A. Same way A with B, A with C, A with D. For example, let us take this K value to be distance matrix. Previously we discussed about distance metric of distance of P, Q. So instead of P and Q, I can use A and A. Since A and A is there, B value will be equal to 0 because both are similar feature vectors. Whereas if I take the similarity A and B, I will get some value. Same way A and C, similarity A and D. So this similarity values I'm going to take it as A dash. So this is my new data point or derived data point from my original data point. Same way I try to do it for B dash, C dash and D dash. Now using this A dash, B dash, C dash and D dash, I try to draw a line and try to separate out the data. If it is not possible, what I have to do, again I have to project this data to the next dimension. What I can do, I can find again, I will do some other function f of A dash, comma, A dash, comma, again f of A dash, comma, B dash. So like that it goes on. It is equal to A double dash. Same way I find B double dash, C double dash, D double dash. Then using this 4 data points, I try to fit the data. So from my data, I try to derive some information and try to segregate based upon that information. If I'm not able to do, again from that information, again I try to derive something. So like this, I keep on projecting our data from one dimension to the next dimension. So if I reach to a particular point where I can divide my data, I will stop at that. So this type of algorithm is called as a non-linear SVM algorithm. So here for simplicity, I have said something related to a distance metric. So instead of this distance metric or distance function, I can use other functions also. Like I can use a linear function, I can use a polynomial like this sigmoid function, or I can use a radial basis function. So these are some of the functions which I can use it for my k. So linear function means x transpose y. Polynomial means this equation. Same way sigmoid means this equation. Radial basis function means this equation. So final algorithm which I am going to discuss is your logistic regression algorithm. So here I have 2 classes. It is basically used for binary classification, 0 or 1, true or false. So here what we do is we take an image. So let us assume I have an image. I extract the features from this image. So I get a feature vector like this. So V equal to V0, V1, V2. It goes on till Vn. So here I have a n dimension feature vector. Okay, since I have V0 to Vn, I have n plus 1 dimension, because here I have V0 also. So it is n plus 1 dimension feature vector. So once I extract the features from the image, I assign weights for each and every feature elements. So we try to put W0 as a weight for V0. Same way W1 for V1, W2. So here I put W0, W1, it goes on till Wn. So this is my weight element. So I try to assign weights for each and every feature element. What does this weight indicate? It gives the importance for the feature element, whether that feature element is required for my final classification or not. For example, if my W0 is equal to 0, what I have, if I multiply this with this one, so when I execute this function, what will happen? It's nothing but W0 V0 plus W1 V1 plus it goes on till Wn Vn. So if my W0 is going to 0, then this term, entire term will go to 0. Then my V0 is not needed for my final classification. So my W0 is the one which is going to specify the weight or importance of the feature element. If I put it to be 1, what happens? Then this V0 is going to play a role in my final classification, whether it is important or not important. So that we try to decide using this weight. So once I do this operation, I will get a single value, x. So that is this. So this x, I try to put it into a sigmoid activation function. So this is a sigmoid function. So here I put s of x. So it is equal to 1 divided by 1 plus e power minus x. So here if I solve this, I will get a s curve. For different values of t, I will get different values of s of t. So if I put s of x, it will come to a certain value. For example, let us take, I take an image, extract the features V0 to Vn, multiply it with Wi to Vi. So let us assume that our x value is equal to 1.2. Let us take this 1.2, and this image is going to have something related to cat. Let us assume the ground truth value is cat. It gives a value of 1.2. Then I try to go to the sigmoid function. So 1.2 is somewhere here. So if I draw a line, so this is my x, this is my s of x. So it comes somewhere. So here I divide. So around 0 I divide. So here this side I will take it as cat, this side I will take it as dot. So what is my prediction? This point. This point is my prediction. So what it predicts? Cat. What is my ground truth value? Ground truth value is also cat. So there is no error. So for example, if my prediction is x is equal to minus 0.5. Let us take x value comes up to be minus 0.5. Then what happens? Minus 0.5 means it comes somewhere here. So this belongs to dog category, this belongs to cat category. So what my algorithm predicts? Algorithm predicts it as dog. But what is my ground truth value? Ground truth value is cat. So there is a misprediction. So it results in an error. So if I want to correct it, what I need to do? Only one thing which I can modify is our weight parameter. If I change my weight parameter, what will happen? This x value will change. If my x value goes x greater than 0, x greater than 0 means it is coming to this region. So when it comes to this region, it becomes cat. Then my predicted value is matching with the the ground truth value. At that time, I stop updation of my weight values. So this process is called as the learning process or teaching process. So I initially assign random weights, make a prediction. When prediction is wrong, what we do is we start updating our weights. Thereby, I reduce the loss function. So, for example, here I take, so here something related to like this. So here I have J, which is our loss function. So loss function is nothing but predicted value minus ground truth value. If P is not equal to G, then J will be high. So if I have J equal to high, means what? Initially, if I set some, so let us assume for simple, I'm going to use only one weight, W0. So in that case, initially let us assume that my W0 is here. So my loss function is, so my loss is maximum. So as I start updating my W0, as I keep on changing my W0, what happens? Slowly it goes to a minimum value at this point. So at this point, I have low loss. At this point, I stop my updation. So this is my optimum value of W0. So this process is called as a logistic regression algorithm. So from top side, if I view, it will be looking like this. So initially, I have high loss. As I start updating my weights, what happens? Slowly it goes to a very, very optimum value. So at this point, I have a minimum value. So this is regarding a logistic regression algorithm. So now let us try to discuss about the performance metrics. So any machine learning algorithms will have this performance metrics. So here is something related to 4 important parameters. One is true positive, true negative, false positive, and false negative. So here I try to represent this using so here I have predicted value, here I have a ground truth value. So let us take this as 0 and 1. Same way here I have 0 and 1. So here in case if I want to do CAT classification, so let us take this as category 0. So CAT I'm going to take it as 0. Then what happens? I need my label is CAT and my predicted value is also CAT. So then this is called as true positive. So my ground truth and prediction are same. My ground truth is also CAT. This is also CAT. This is called as true positive. Whereas instead of my ground truth value is CAT, but my machine predicts it as other category. So let us take this one as other category, other than CAT. Then this is a false negative. Same way, if I try to take this one, my ground truth value is other category, but my machine predicts as CAT category. Then it is called as false positive. Same way, in here also, I have my ground truth value is other category and my machine prediction is also other category. Then it is called as true negative. So like that, we try to identify our true positive, true negative, false positive, and false negative. From these 4 values, I can calculate the accuracy, precision, and recall. Using this precision and recall, I can compute the F1 score. So F1 score is a parameter which can give how stable is our system to an unknown data. So if I have a large value of F1 score, then our machine is expected to work very well under a new data set. So these are some of the parameters associated with your machine learning. So now I will try to show you a demonstration of machine learning algorithm. So I will open a Jupyter notebook. So Jupyter notebook is a interactive platform where I can write codes and execute the codes as well as. So here I am going to explain about an important classification of handwritten digit recognition. So if we have handwritten digits, I have to provide these digits to our machine so that it needs to assign some labels to the handwritten digits. So digits in the sense numbers from 0 to 9. We have 10 different classes. So we have a data set called as MNIST data set, which has about 60,000 training images, 10,000 testing images are there. Since it takes more time to execute the 60,000 training images and 10,000 testing images, we are going to use a subset of this MNIST data set, which is available in your scikit-learn package. So this is a machine learning package. There we have a small subset of this MNIST data set, which has about 1797 handwritten digit images. Since the number of images are less, I can execute the code and you can see the output in real time. If I can also execute this, but it will take more time. It will take some 10 minutes for computation to give me the result. So here what we do is we divide it into training, validation, and testing. Because here I'm going to use k nearest neighbor algorithm. In k nearest neighbor algorithm, as I said earlier, we have some hyperparameters to be tuned, like distance metrics or k values I need to identify. So for simplicity, here I'm going to use Euclidean distance metric, and the k value I'm going to identify. Which k value is going to give me a better performance? That we try to identify with the help of a validation data. So some characteristics of this data set are each image in this data set is going to be made up of 64 dimension pixel intensity picture vectors. It is essentially a 8 by 8 grayscale image. So 8 by 8 in the sense you will have about 64 pixels an image. So pixel intensity picture vectors. So the important thing about the images, I have a black background with the digits are written in shades of white or gray. One important thing here you have to notice, these images are heavily pre-processed. Pre-processed in the sense noises have been cleared and the digit is exactly at the center of the image. So it is perfectly aligned and centered. So if you write something in notebook, if you take a photo, then you have to do some pre-processing before giving that input image to this algorithm. So that you have to know. So now what we are going to do is we are going to execute a k nearest neighbor algorithm to identify the handwritten digits and classify these digits. So in order to explain this, we are going to use certain packages. So here I am going to explain the code in terms of Python binded with your OpenCV. So OpenCV is computer vision package, which has a lot of image processing libraries and embedded. So here we are going to import certain packages like sklearn. So sklearn is a machine learning package. There's a lot of machine learning algorithms. Same way skimage is for representing the data in terms of an image. Because the data has to be converted into image, means I need to assign the intensities to each and every pixel. So this can be done by your skimage. Same way, I have another package called as numpy package. Since our images are represented as a matrix, I need to work with this matrix. So here I use a numpy package, which is a numerical Python library, which is used for your matrix computations. Then I use a third-party library called as IMUtils, which can be used for resizing an image, rotating an image, translating an image. Like that, we have a lot of convenience function associated with this IMUtils package. Same way, I can import the CV2 is a computer vision version 2 library. So these are some of the packages which I need to use in our program. So from this sklearn package, I import a class called as train test split. So this function or this class, it is going to split my data set into training data and testing data. Same way in sklearn package, I also have the machine learning algorithms like k-nearest neighbor, SVM, logistic regression. So we have a lot of things. In our program, we are going to use k-nearest neighbor. So I make use of the class k-neighbors class. So in order to see my result, performance metrics like accuracy, precision, recall, I am trying to import this classification report from this sklearn package. Then, as I said earlier, a small subset of our data set, the MNIST data set, is available in your sklearn package, so that I can try to make use it with the proper data set. Then in SK image, as I said earlier, I need to convert my data into an image, so I try to use a function called as exposure. So exposure is each data will be assigned with an intensity value, so that instead of using numpy in short form, we write it as NP. So these are the packages which I need to import in our program. So first thing, after importing all the packages, first step is I need to get the data set from our library package. So I try to use this data set function, load digits is a attribute in this class data set. So in making use of that to retrieve that 1797 and written digits are obtained, and it is placed into the variable image. So now the first step is collected. So I have the data set. So after getting the data set, what I have to do, I have to divide my data set into training data and testing data. So how to divide it? Using this function called as train test split. So remember, since KNN is a supervised learning algorithm, so each data will have a ground truth value. So when I divide my data set into training data and test data, I should divide my data as training data, training labels, test data, and test labels. So I give the entire input. MNIST is my input where I have all the data. So I give both my data as well as the target. Target is nothing but the labels. I give it as an input for this train test split. So now I have to specify the ratio. In what ratio I should divide my train test split? Whether it is 80:20 or 75:25 or 60:40. So that can be specified using this test size equal to 0.25. 0.25 means here I am going to do training 75% of the data, testing 25% of the data. Then I assign a random state of 42. So here this random state is used for shuffling your data. I have to shuffle this 1797 digits before splitting it into training data and test data. So for that we make use of this flag called as random state. So here we try to assign an integer value between 0 to 42, which will give more reproducibility. When I run the code for subsequent times, the reshuffling will be more synchronous in nature. So once I execute this function, I get 4 outputs: train data, train labels, test data, and test labels. So we get train data with the train labels, same with test data with test labels, it will be separated. And as I said earlier, here in KNN, different values of K will give me different accuracy. So in order to find which K value is going to give me higher accuracy, I am going to divide my training data into training data and validation data. So how I am going to do it? Again, use this train test split function. Here the input for this function is training data and train labels. Previously it is the entire data set. MNIST.data and MNIST.target, I divided into train data and test data. Now I give train data and train labels. Again I specify the test size. So now out of 75% training data, 10% I am going to keep it for validation. Remaining data will be available for training. Again, we specify a random state value. So now you can see they use 4 outputs. One is train data, train labels, validation data, and validation labels. So this validation data and validation labels is used for finding which K value gives me higher accuracy. Then for that K value, I need to retrain my system before exposing my machine to a test data. Now I print it out and see what happens to my train labels, validation labels, and test labels. Now, altogether, I had about 1797 handwritten digits. It is divided into 1212 for training, 135 for validation, 450 for testing. Then I assign a K value to vary from 1 to 30 with an incrementation of 2. So I take K values 1, 3, 5, 7, 9. It goes on till 20. Then accuracies, right now we have not executed anything, so I created an empty list. Then using a for loop, I try to create a model. So now two steps are over. One is collection of data set. Second one is splitting the data set into training data and testing data. Now next step is I need to perform feature extraction. Here I am not going to do any feature extraction process. Here I am going to use the actual pixel intensity itself directly for my K nearest neighbor classification. So feature extraction is ruled out. So I go to the fourth step called as train the classifier. So in order to train the classifier, first I have to create the model. So I create the model K nearest neighbor. I specify how many neighbors I should have. So here this K value is going to change. When this code runs for the first time, my K value will be 1. When it runs for the second time, it will be 3, 5. So it keeps on changing till it reaches 29. Once I created a model, using this model, I try to do a training process. How to do a training process? Using this simple command called as model.fit. So this fit function is going to do the training. So for training, what I have to give? Both training data as well as training labels, because when my machine makes a wrong prediction, I need to correct it. So I need to give both the data as well as labels. So I give both training data and training labels. Once my machine is trained, I need to validate my K value, or I need to find the accuracy using the validation data. So I use a function called as model.score. Now I use validation data and validation labels. So this gives me accuracy value. So I try to print it and see. So here if I execute this code, it will give something like this. For K value 1, my accuracy is 99.26. K value 3, again 99.26. If my K value is 17, 98.52. So here you can see that as I change my K value, accuracy gets changed. So what I do is I need to pick the K value which gives me higher accuracy. So for example, here K equal to 1 to 15, use the same accuracy. So I can pick K value 1 as my optimum value. So for this K value equal to 1, I should retrain my So I by here showing K equal to 1, achieve higher accuracy. Then using this K value, again I am doing train. Model.fit on train data and train data. So this validation data is used only for identifying which value of K gives me the best result. Then for that K value, again I am going to retrain my system. Once I retrain my system, now I start exposing my test data using this function called as model.predict. So during testing, I am not going to give labels because it is just the evaluation. It is going to give 1 or 0. So it is not going to correct the machine if my machine makes a wrong prediction. So I just make a score, then print that score using the classification. So here you can see that if I execute this, you will get this result. Here you can see the precision, recall, F1 score, support, different parameters. These are the different digits which I get from 0 to 9. So here you can see that the digit 0 or the image which has digit 0 is 100% of time it is rightly predicted. Whereas 1, it has some small error, 95% is predicting properly, whereas 5% some errors are same way. 2 is 100%, 3, 4, 5, 19%, 6, 7, 100%, 8 and 9 some 96% it is predicting. So overall performance of the system is shown here, 98%. It is accurately predicted. This is digit-wise. Digit-wise performance. This is overall performance. And here you can see one more term called as support. So this support indicates How many test data? I had about 450 test data. Out of this 450 test data, how many test data are there for digit 9? How many test data for digit 8? Same as 7. So here you can see that for each class, how many test data has been checked for our machine. So that is what gives the subgroup value. So in order to better understand what we do is we pick some random 5 images out of this test labels. Out of 450 images, I pick some 5 random images, then try to show that image and what is our prediction here. So let me just execute this code and I will show you the code. Now it is getting executed. So packages are being imported. So train data test script, then train test validation script. So here you can see that it's divided. Now I run this program for different k values. Now identify the k value with the largest data. Then here I execute it for. Now as I execute this code, you will try to see an image with some handwritten digit. Then what is our prediction? So here you can see the image. So this is our image. I pick randomly 5 images. So this is 6 and our algorithm is also saying it is 6. So it is rightly predicted. So if you press a key, then the next digit, here you can see that it is showing 4 and our algorithm is also predicting it as 4. Right? So here next is 0. Our algorithm is predicting it as 0. Seven is also the right vector. So this is regarding your AMN algorithm. So here I have used a very small subset of data. So now I will try to show you if I want to do it using the actual data set, then what we need to do. So here I am not going to execute the code. I will just describe few changes. Because when I try to execute this code, it will take more time to give me the result because it has more number of training images, 60,000 training images and 10,000 test images. So few modifications are there when compared to your original code. So here as usual, this functions and all it is same, train test script, k neighbors classifier, classification report. Now, in order to get that MNIST data set, it is available in your Keras library package. Keras library package is an advanced machine learning package. Here it has a lot of machine learning algorithms embedded into it. It also has a data set called as MNIST data. So it has about something 70,000 images available in this Keras library package. From that Keras library package, I try to import the MNIST data set. Previously, we used Skykill. Finding the path of the image, IM methods and CV2. So here as usual, I use this MNIST.load data to get train data, train labels, test data and test labels. Then what we do, we convert this image into a feature data. So here the image in MNIST data set, my image
Sir,
is going to
sorry for the interruption. We do have a polling session now. Shall I launch it now, sir?
just 2 minutes I'll complete.
Okay, sir. Okay, sir.
So here we try to load this data set into X-train. Y-train is the labels, same way X-test and Y-test is the labels. Here I try to convert it into number of pixels. So number of pixels is nothing but our image is going to have 28 by 28 images. So I will get about 784 dimension vector. Then I try to normalize this function. Then as usual, I do train test split with 10%. So here you can see that 54,000 is used for training, 6,000 is used for validation, 10,000 is used for testing data. Same way, I try to run this code for different k values. Then here I have run only for 2 times because it will take more time to give me the result. So for simplicity, I have run only for 2 times k equal to 1 and k equal to 3. Then I try to identify how much accuracy is obtained for k equal to 1. Again, retrain my data for the best k value. Then finally predict the result. So this is regarding how to import the actual data set and do the work process. So this I will start. If you have any queries, I will try to answer. Thank you.
I request all the attendees or participants to answer the poll. The poll will last for 5 minutes. So I request all the participants to answer the poll. I repeat, participants, you can answer the poll. So it's time for questions. Participants, if you have any queries or doubts, type in the chat box. We'll pick your question and ask our speaker. I repeat, if participants have any doubts or queries, do type in the chat box. We will pick few questions and ask our speaker. We have got question from Sivakumar sir. Misbehavior detector methods, which algorithm is the best?
Can you repeat it once again?
Okay, so sure. We have got a question from Sivakumar sir. Misbehavior detected methods, which algorithm is the best one?
Misbehavior detection method. What they are trying to identify?
For that one, which algorithm is the best one? He is asking which one is suitable for this misbehavior detector methods.
No, I'm asking about something like anomaly detection. Is it related to anomaly detection?
Sivakumar sir, are you there? Okay, fine. We do have another question from Sachin sir. For classification, which is suitable algorithm? Object classification. For object classification, which is suitable algorithm?
Random forest used to give a very good result for object classification, but again it depends upon your data set. So if your data set is very good, then random forest will surely work. So if it is a little bit poor quality, then SVM with some non-linear converters might work as well. So then one more query is the retinal image database to extract the blood vessel which algorithm. So here again, in order to extract the blood vessels, you need to do some segmentation. So segmentation of the blood vessel, then you can apply some classification to do that identification. So you can try with some graph cut method. So graph cut method, you can try to segment the blood vessel, then try to identify it using some classification algorithm. So misbehavior defection for real-time application. So here in terms of real-time application, if you want to do it, so mostly your deep learning algorithm with the transfer learning technique might be very well suited, because for real-time implementation, since the data set is going to come from a real-time environment, our algorithm might not have seen such images during the training phase when I try to do it with a normal machine learning algorithm. So it is always better to go with the deep learning based system, so that lot of information can be gathered and lot of things can be predicted when I go with the deep learning system. So that is what I can suggest for real-time application. If you want to do some misbehavior defect detection, then deep learning algorithms with the transfer learning. Transfer learning is something related to get the knowledge from already pre-trained models, use it in your own system, so that you need not retrain your system from scratch, so that the computation time can be a little bit smaller, so that you can try it. In KNN, K value has limit. No, so K value, it doesn't have any limit. You can try. So usually the K value, low values, K1, K3, it will try to give a better result. As the K value increases, what will happen? We try to compare our data with a lot of neighbors. Then the accuracy will get affected. So the smaller value of K will be better, but K value, it doesn't have any limit. What about CNN? Yeah, that is what for misbehavior detection for real-time application. I said it's deep learning systems. So deep learning systems are based on your CNN models. So your CNN models only, it will perform better in your real-time application.
A small announcement: to get e-certificates, we consider only the number of minutes that each individual participant spent in this webinar will be taken into account. With that basis only, we will provide certificate, and not by submitting poll and feedback. I repeat, to get e-certificates, we consider only the number of minutes that each individual participants has spent in this webinar will be taken into account. With that basis only, we will provide certificates, and not by poll and feedback. So any more questions? If you have any questions, do type in the chat box. Sure, sir. We will send the schedule in the group. It was a very informative session, sir. I thank our speaker, Dr. Satish Kumar sir, event coordinators and event co-coordinators, and you, the participants, for making this session as a possible outcome. I once again thank everyone who has spent your quality time in this session. So this is Abareshwar winding up the session on the day 2. Hope we shall see in the next session, which is tomorrow morning. Thank you all.